Okay, let's get started. Sorry for the slight delay in starting. Today we're going to be starting the Pokemon Nuzlocke, Pokemon Hardcore Nuzlocke AI creation. Let's just start by introducing what the project is, what is a Nuzlocke, what makes it a hardcore Nuzlocke, and how on earth are we going to make an AI to do this whole thing. So, to start, Pokemon. It's a game that people have played from ages 2 to 102. It's a game that is very accessible to everybody, and because of that, it tends to be very easy to win. In fact, each generation, each game that comes out, they keep adding more and more ways for the game to become even easier and more accessible for more audiences. It's a common complaint, actually, that it can be too handholdy and too easy. So a lot of people will run self-imposed challenges where there's permadeath, where a Pokemon will, once it faints, it's gone for good. Additionally, people will play with even more strict rules, such as on each route you can only catch one Pokemon at a time. And if that Pokemon faints, it's dead, and you can't get any more of the same species. A hardcore Nuzlocke is an even more restrictive form of that. It means no items in battle. You play on set mode, so if you faint an enemy's Pokemon, normally when you're playing you get to switch yourself, but in this case when it's set, it's set. You don't get a free switch. It makes you play a little bit more cautiously as well. So what we're going to be doing is we're going to be training an AI to play under these rules, these hardcore Nuzlocke rules. And while right now our idea is to train it to beat Pokemon Black in a hardcore Nuzlocke, based off of what we see from what's possible and what we can do, we might switch the game. But for now, the idea is Pokemon Black, hardcore Nuzlocke, entirely done by an AI. So let's get started. What we need to do in order to really solve this problem is figure out where are we going to be introducing AI and how are we going to create that AI. I've got a whiteboard pulled up right here so that we can kind of deconstruct this problem, and this applies not just to this kind of fun AI problem, but any sort of real AI problem. You always want to start on a whiteboard and start by deconstructing the problem. And the way I'm visualizing it right now is there are kind of two main things that we need to do in order to really have a Pokemon playing AI. The first one is team building. A core part of Pokemon is having your team of Pokemon and training them up and deciding what order they go in and what moves they know in order to win battles. If you were just playing with a random team each time, or worse, just playing with whatever you get by running through the game, never put any care into team building, it's very possible that you'll run into an enemy trainer that perfectly counters your team just by chance, and no matter how skilled you are at playing, you just can't really get around it. So we'll want some amount of AI improved team building. That way we can leverage that skill and create an AI that can, using the limited pool of Pokemon it can have playing by Nuzlocke rules, build a team that will do really well in the battles that it has to play. The second part that it really needs to do well in is, of course, battling. Unlike in competitive Pokemon, Nuzlocke battling can be even more difficult for us to plan around, because in a Nuzlocke, especially a Nuzlocke of a whole game, any deaths carry on with you into future battles. In competitive Pokemon, it's okay to sacrifice a Pokemon here or there if it means winning the battle, because all that matters is the battle. In this case, what matters is the run. So we want to be training an AI that can minimize the loss of Pokemon while still winning each battle. So that AI will need to consider when is it absolutely necessary to sacrifice and doing it, but otherwise winning without losing Pokemon. It's not enough just to win, you need to win by a long shot, or at least by not losing any Pokemon. So, now that we've kind of split it into these two categories, let's start by listing ways that we actually even could introduce AI into team building. And then after we list ways that we could do AI in team building, we can also figure out how we can introduce AI into battling in general. These two things will be separate AI projects where we want to take in some input. For example, the opponent's team. And it's going to go into some sort of AI that then, based off of the opponent's team, we're assuming that the AI gets to use a walkthrough and see what the next battle is and build a team for that next battle. It will then also be constrained by the Nuzlocke rules, so no 2 copies of a Pokemon. If a Pokemon has died in the previous battle, then it can't use that Pokemon or any of that Pokemon's evolutionary line, and so on and so forth. And it will have to spit out what team to use. Additionally, it will need to spit out what level each Pokemon should be, keeping in mind the hardcore Nuzlocke rules of a level cap, what items they should hold based off of the items that are available at that point in the game, so on and so forth. So the idea is that we'll kind of do things in 2 steps back and forth throughout an entire run. So the way we can picture this is that we will have probably over 100 required battles in a single game of Pokemon. We'll have to actually investigate a specific game. In this case, we're going with Pokemon Black. But if we find that the resources are somewhat limited, we can pick a different game based off of what we find. So the idea is that there will be kind of pairs of AI runs. There's going to be a team building phase, which I'm just going to put TM for team. Maybe TMBLD for team building. And then after it team builds, it's going to do a battle. So it'll team build for this next battle, then it will actually do the next battle. If the battle goes well, and that is, they don't wipe all of their Pokemon, then they'll continue on. However, if they lose the battle, the run is over, and you have to start back from the beginning, and it was not successful. So what we'll do is it will team build battle. This battle will then unlock some new items, potentially. Like if in Pokemon, after you get past a certain trainer, then you can pick up a TM for Thunder Wave or something. Then that will become a potential move that it can teach Pokemon. So there will be another third thing, which will be update the possibilities. So after each battle, for example, after each badge, it allows you to use different HMs. After each gym, they typically will give you a TM, so that will add that move to the possible moves. As you progress through the game, you can unlock new routes, so you can get new Pokemon, so on and so forth. And then this process will repeat. Then there will be some next required battle that will require some team building. And then another battle. And then another update. Etc. So on and so forth until the final battle. In a typical Pokemon game, this is the Elite Four and the Champion. Depending on the game, it can be slightly different. For example, with Pokemon Heart Gold and Soul Silver, you typically will go not just to the Elite Four and Champion, but all the way to Red, who is the kind of final boss of Heart Gold and Soul Silver, and like Gold and Silver. In Pokemon Black, spoiler alert, you don't just fight the Elite Four and the Champion. Instead, you fight the Elite Four and then N and Ghetsis, the 2 main antagonists in Pokemon Black and White. So the run ends in Pokemon Black after you beat Ghetsis. So assuming you get through every single battle and you beat Ghetsis, we'll have created an AI that has successfully Nuzlocked Pokemon Black in hardcore Nuzlocke rules. So one of the things that we'll have to do outside of AI training is construct this run, so that everything can happen in the proper order and we can actually evaluate our AI and see if it's worked. If it doesn't, then clearly we've got to start from scratch or improve some of the AI. We can diagnose what went wrong. Did it just pick a bad team? Did it make dumb mistakes during the battle? What went wrong? And we can see it improving over time. If it just manages to luck its way up to like the third gym and then it loses, we can evaluate where it happened and see how to improve it. So the team building, that's one AI. And there's a couple of different ways to do it, but typically whenever you start thinking about constraint AI, that is AI where the rules kind of change a little bit over time and you're playing some game, you tend to move towards so-called reinforcement learning strategies. And what that is you're building a kind of space of different actions that the player can take. For example, in Pac-Man, you can move the character, Pac-Man, in one of the four directions, up, left, down, or right. So when playing Pac-Man, those have you have four actions at any time you can do. However, if you're right up against a wall, you can't move into the wall. So maybe you would take away that action. What this is doing from an AI standpoint is you're adding constraints that under certain circumstances, the AI can't do certain things. Like when you're playing chess. If you're in check, you can't just move one of your other random pieces. There are constraints at different times. But if you're not in check, then maybe it's okay. Similarly, when we're building a team, we're going to have rules about what Pokemon we can pick, what level they can be, what held items we can give them, what TMs will be available to update their movesets, and so on. These restrictions will make it much more realistic that the AI is playing the actual game. Because we're not training the AI by actually handing it a controller and telling it to play Pokemon. Instead, we have to write this environment that mimics what a Pokemon game is doing so that it can learn how to do it in thousands and thousands, maybe hundreds of thousands of iterations of the game to learn how to beat the game. So, team building, it will be constrained by a certain set of rules. And this is the more Nuzlocke-centric part because it cares about limiting what can be done based off of the Pokemon it's encountered so far and the level caps that come along with a hardcore Nuzlocke. So this will probably involve reinforcement learning. What we can do is we can have it pick a team, then simulate a battle. If it won the battle, then it gets points because of that team. If it lost the battle, then it loses points. To make this not purely based off of the battling AI, we can simulate a bunch of different AI. Like we can do just a simple random move. Like, is this tool better if you just randomly move? Is this tool better if you pick the move that has the best damage each time? Is this a better one using our actual battle AI? So on and so forth. And if it wins, then that change that it learned in the team building will stick. If instead it changes its ideas about the team and it starts losing more, then we know to alter it the other way. So it kind of learns by doing. And that's the main idea of reinforcement learning. Is you don't learn by teaching it a bunch of lessons ahead of time and historical data of what was good. Instead, you just have it do things. You have it go out and try and fail and try and fail and try and fail. Hundreds, thousands of times, but each time it's trying out different things. There's an element of randomness to it, and it can kind of pick up on what started to be successful. So we'll probably take the same approach to team building. That it'll start by just picking a random team out of what's available for its Pokemon. It'll simulate the battle, and if it succeeds, then that's plus some points. If it loses, or if it loses a single Pokemon, or if it's very, very close, it'll lose points. So the more points, the better the battle went. The less points, the worse the battle went. And so that's how we reinforce good behavior in the model. Secondly, is battling AI. This, from a concept point of view, is actually very simple. We'll also do this reinforcement learning approach. But what we'll do is we'll just give it a random team, or perhaps give it any team in the team built from the team building AI, or competitive teams that were used in Black. You can do a mixture of all these different things to get more data and more randomness in there. And once again, you just simulate battles. If it wins by certain amounts of margins, then it improves, and it chooses different things. So what we'll do is, this is more of a cycle where it will be fed the certain game state. So what's going on, what your Pokemon are, what the opposing Pokemon are, what all the available actions are. Sorry, I'm writing this with a mouse, so it's a little bit hard to write. That's going to be fed into the AI, and it will select an action to take. Based off of that action, the game state then gets updated into a new game state. Maybe it tells you to switch to a different Pokemon. So you switch to a different Pokemon, the game updates, maybe the opposing Pokemon KO'd your Pokemon, and now there's a new game state, and the AI has to make another action. And based off of the feedback at the end of, oh, you lost a Pokemon, or oh, you won the battle, or you won it but you were holding on by just 1 health, etc., we can then update the AI and improve it over time. So just to clear things up about the differences between these two, for team building, the key thing to remember is that we are wanting to improve an AI that gives a team to use. And what we hold constant is the team building AI, and we change up how the battling is done. So we try different battling AI. Then, with the battling one, we try different teams, but keep the same approach to battling. That way, both of these can be kind of done independently. We can have the team building training on its own and saving the best version of its team building AI to a file. We can have the battling AI running on its own, saving the best battling AI on its own. And then we just smash them together whenever it's time to actually play. So this will try different teams. Some built by our actual team building AI, eventually all of them built by the team building AI once it's good enough. But otherwise just random teams out of the available ones, even like competitive ones if we just want to make it a general good battling AI. Sorry about that. I just had a knock on the door that I had to deal with. And now we're back. So, where I left off is we were talking about the separation of the different AIs, and the idea is that we can just train these both independently in order to give a really solid performance model for the run. And we can also identify what's going wrong. We can investigate which AI is causing the problems by looking at an individual battle and seeing, hey, did it just have a completely nonsense team? Did it just not even level everything up to what the level cap was, and it just have a bunch of nonsense? If that's the case, then we know that we need to go back to the drawing board for our team building AI and improve it. If, on the other hand, it's the battling AI that's the problem, and that it has a great team, but then it just spams protect over and over again, and it just fails, and it gets knocked out, then clearly the battling AI is broken and we need to go and fix it. The most important takeaway, splitting your project up into pieces allows you to tackle the problem much easier than if you just have it all one component. There's a lot of end-to-end machine learning that happens nowadays, and that can be very good and very powerful when it's appropriate to do that. However, it makes your problems that you could face in it much harder to diagnose. If you were to just give it an opponent team and have one AI that then does both team building and battling and everything else in it, you can probably not really figure out how to improve it if it's just not doing well. So by breaking it up into reasonable chunks that then we could train completely independently, this solves the problem, even if both of them use the same approach. One last thing I'll say about this before we move on to the next thing is that this actually does let us try out different approaches. We've said reinforcement learning for both so that it's still based off of the battle results, but we could also do team building based off of competitive Pokemon, and instead of doing reinforcement learning, it does like clustering to try to, out of the Pokemon that it has available and the combinations of Pokemon that it has available, it tries to find the best set that match what competitive users use. That could be a viable alternative, and then there's no reinforcement learning approach at all. You train it completely outside of battling AI. As for battling AI, you're basically locked into reinforcement learning because it's a game that's multiple turns. This is the very classical approach, but you could also do it outside of a machine learning approach. You could try to just make an AI that's rule-based, that just follows a certain set of rules, similar to how the actual trainer AI works. Now, of course, the trainer AI are not perfect, because you can win a game against a trainer AI. It's unlike chess AI, where chess AI you'll never beat. This is a lot harder to do, and also most chess AI uses these types of reinforcement learning approaches. So let's go ahead and move on to the next step. I am very new to this tool, so I need to figure out how to save this. Or maybe I can just go and create a new whiteboard. There we go. So let's talk about Pokemon and how we're going to get this information. So what we can do is we can use this tool called Cerebi. And for now, let's go to Cerebi and let's check out Pokemon Black and White. So from Cerebi, we can see all sorts of information about the game. Let me zoom in a little bit so you can more easily see what's going on. We can check out the Pokédex and the actual learn sets of all these Pokemon so that we know which moves the different Pokemon should know. We can check out which routes the Pokemon show up, so we can find out which Pokemon should be available at what point. And of course, we can find the trainer teams so that we know whenever we're creating this run that has battle after battle after battle, what the battles actually are, and what order they should appear in, with what Pokemon, what held items, levels, etc. So that lets us build the actual game, at least from a content perspective. So for example, we can see the very first gym is the Straton City Gym. I'm not actually sure how to pronounce it. Straton City Gym. And this depends on what starter you pick. So this depends on the team building component. Whether you pick Snivy, Oshawott, or Tepig, the 3 starters of this game. And based off of that, that'll influence the battle. We probably won't care too much about picking the best starter, because Pokemon Black isn't a hard enough game where you can only choose one starter and win. People can choose typically whatever starter they want and win. So we might just have the AI pick a random starter and go from there. Otherwise, we might, in the team building AI for that very first battle, let it only pick Tepig Oshawott or Snivy just once, and then based off of which one it picks, that's the choice it made. It depends on whether it is crucial to the AI's performance that it gets to choose what starter it gets, or if we can kind of just give it a random one and be perfectly fine. Either way, we can see that every single Pokemon that every trainer has, what level they are, what their ability is, what attacks they have, whether or not they're holding a hold item, and so on and so forth. This lets us build up the run as just being like maybe some sort of JSON object or CSV of each row being a different trainer and giving it all of the Pokemon in that row. We can then customize it based off of different things so that we can adjust this, or you can make this apply to Pokemon White or Pokemon Black 2 or whichever else. We want our code to be general. We don't want to just create an AI that only ever works in Pokemon Black and then that's it. We have to start from scratch in order to do Pokemon Emeralds or something. So instead we'll try to stick to doing as general things as possible. So by using Cerebi, one of the things that we can think about is we need to build this run, which has team building component, battles, etc. So what it's going to look like is for the team building, it will have a list of possible Pokemon with percentage likelihoods of it being the encounter. So what we'll do is we'll say Pokemon A, maybe something like Tepig, has a 33% chance of being your encounter for the first route, or for the first town. Snivy has a 33% chance of being your encounter for the first town. And Oshawott has a 33% chance of being your encounter for the first town. So what would happen in the very first stage is these are your encounters that you've unlocked up to this point. A random one would be chosen. So in this case, how about Tepig? So Tepig is now added to the choices. So this is the encounter, like potential encounters. This is now the actual box of Pokemon. Then you are constrained by the current level cap. And you can pick 6 Pokemon. So in this case, the AI would look through the box and say, okay, the 6 ones I'm going to pick are Tepig, and then I don't have any other choices, so that's it. So I'm going to assign Tepig to slot 1. The current level cap for the rival fight, which is the very first fight, is 5, because you can only have a level 5 Pokemon. So it's going to be level 5. And it's going to know the default learn set that Tepig has. So its moves will be blah, 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 blah. You don't have any items, so it won't be holding an item. And we'll, at encounter time, any sort of IVs will be assigned randomly. And for the sake of making this easier to simulate, we will be setting every EV, which is a hidden value that increases over time based off of the training of your Pokemon against different other Pokemon. We'll be setting all of them to 0. This is just another technically notch up in the difficulty, though most opponent trainers don't have EVs either, so it's really just leveling the playing ground. So this chooses your Tepig in the team building. But just as easily on a different run, It could have instead been a Snivy or an Oshawott, or an Oshawott that's a different gender and has different IVs. So there is an element of randomness, but there's an element of randomness to a real Nuzlocke, so our model shouldn't just force specific encounters. So this is the team it's chosen, based off of the level cap, the items that are available, and the opponent team. And what is the opponent team? Well, in this case, it is a just whatever starter you didn't pick. So the opponent team, so this is your team. This is the opponent team. With each of their 6 Pokemon. Up to 6 Pokemon. In this case, it would have been an Oshawott. Also level 5. And we'll set all IVs to 0. And all EVs to 0 as well. If we can find out what the real IVs and EVs are, if there's any sort of data set that has that information, we'll absolutely go to that. But otherwise, we'll probably just set EVs to 0 and IVs either to 0 or 31 across the board. It depends on what we can find from resources on the internet. So it has an Oshawott that's level 5 with its certain moveset and whatever held item it has, and etc. And then we have to simulate the battle, where the player will have this team using your AI and the opponent will have the other team using some sort of kind of trainer AI. Which the trainer AI we will also make ourselves, but we'll, rather than trying to make it as good as possible, we'll instead try to make it as close to the actual trainer AI that's in the games as possible. This is practical because there are a lot of notes on the internet about how the trainer AIs work, so we can hopefully make a accurate representation of that trainer AI. The times that it would switch, the times that it'd use a stat move versus a powerful move, and how it would do that, etc. Additionally, one thing that we do want to go ahead and say here is that we will likely just skip wild battles. This is because it will introduce a lot more complexity to try to do wild battles on top of trainer battles. So while that could technically count as cheating, that we are ignoring one of the main parts of Pokemon, which is going and catching Pokemon, for the sake of having a first run in an AI that can beat a hardcore Nuzlocke, I think we have to pick our battles, quite literally, and it seems to me like it would be okay to just assume that every wild encounter goes your way. You don't lose any Pokemon, you catch a Pokemon in each route, based off of the odds that happen, and you're good to go. So that, let me know in the chat or in the comments of the YouTube video that this is in, if this is something that you think is unacceptable, or your other thoughts about this, or how we might make up for this. The reason why I'm saying that we can skip this battling AI, or the wild encounter AI, is that the tool that we'll be using for simulating these battles is Pokemon Showdown. Pokemon Showdown is an open source tool to play Pokemon. It's not owned and run by the Pokemon Company or Game Freak. Instead, it's hosted by a just community of people who are really into Pokemon and competitive Pokemon, and they have an open source download that you can just run it on your own machine and simulate battles and see how they go. So what we'll be doing is using Pokemon Showdown, as well as this Python library called PokeEnv, to simulate these battles between different AI and see who comes out on top. We can also then check what happened and see the replay of the battle so that we can have it live on stream what's actually happening. The goal of this stream is just the research phase. In the coming weeks, as we're going deeper into this project, we'll be focusing a different stream on team building AI, a different stream on battle AI, and then lastly, once we think we're ready, we will open up our local Pokemon Showdown and we'll simulate every single battle that happens in a run, back to back, and see, can our AI do it? Can it win a Pokemon Nuzlocke in Pokemon Black? So while it won't be playing the official DS game, it will be battling every single trainer in Pokemon that it's required to, with all the real Nuzlocke rules, all the real randomness that happens in a Nuzlocke and just in a normal Pokemon game, and we'll see if it can come out on top. I tend to be really bad at Pokemon Nuzlocke. I get too attached to the Pokemon. I don't like the idea of permadeath in my games. So we'll see if this AI can do better than I can, because I know right now I am not very good at it. But yeah, so it'll simulate a battle. Once the battle is done and a victor is happening, we can decide what to do next. So if it wins, then it's going to go on to another team building phase. However, if it loses, it goes back to the start. So the win just goes on to, again, another team building. But now the next encounter is maybe the encounter on Route 1, what Pokemon you can possibly get there. With the odds, it builds the team again using the team that's already in the box. So the box from before, plus the outcome, goes into the new box. So, like, let's say later on down the line, you have a bunch of different Pokemon, and Tepig faints, and you go on, then the box will no longer have Tepig in it. Tepig is not a valid encounter at the next place, and because you've already had a Tepig, it would never be a valid encounter, even if you did see it on a route, so on and so forth. So the next route we can even check, just for the sake of the example and really spelling this out, what it would actually look like. So let's see if we can find the route. There we go. Unova region database. Let's go to route 1. Which is this route. Yep. There we go. So what we could say from the team building standpoint is that you have Patrat as a potential encounter with 50% odds. And then the other one is Lillipup with 50% odds. Yeah, actually, I do everything in Python. So for now, since we're just in the planning phase, there's no real code. But I've done just not a proof of concept. I can't even really say it's to that level. But at the very least, just like downloading the libraries that I was talking about and running it in Python. So this library that we'll be using for creating the AI is called PokeEnv. And what I have done so far is create just a max damage player, which is on their tutorial of how to do, which just selects which move has the most base power, and it uses that move. And then you can simulate battles using the Gen 5 rule set. On Pokemon Showdown, you can play with different generation rules, and it limits what Pokemon are there and all that. So I just did a Gen 5 random battle between some random players and between this like max damage player to see how it works. And it's all in Python. Pokemon Showdown itself is not written in Python. You do have to install Node, which is like JavaScript, to run it, but you don't have to code in JavaScript. So yeah, exactly. Like it could seem overkill to do AI and all this work for Pokemon, but on the other hand, what else are you going to use AI for? Like, tons of people, like Google invests, tens of millions of dollars in their AI program for chess, and chess is just another game, but they create AI like DeepMind is sponsored by Google. I'm pretty sure they're owned by Google at this point. I don't know the most, but yeah, this library PokeEnv is a way of connecting to like Showdown through Pokemon to then simulate battles. Oh, okay, yeah. So yeah, like just like chess, the more complicated your game gets, the harder and harder it is to create a good AI that can play it. It's why it took a long time to go from chess to a game like Go, which now an AI can easily beat even the best players. And it's why it's even harder for, once you open up all the different actions and what's called as the action space, once that gets bigger, it gets even harder to create good AI. But the objective of this isn't necessarily to create a perfect thing that's better than any other human Pokemon player, but at least to beat Pokemon Black, which is fundamentally at its core a game for children. So hopefully we can get an AI that can be as good as a child playing Pokemon under some harder rules. It can be a little bit of an ambitious goal, depending on how you phrase it, but most of the fun is just from the process. So yeah, we'll be creating this kind of run idea where it'll be team building battle, team building battle, team building battle for all the required battles in the game. This will require a lot of just writing down in Excel or some other tool about what the encounters are, what the required trainers are, finding the route that it can go in. And we'll have to take some caveats to make it simpler for ourselves. For example, we might just assume that it can grind to whatever level it needs to without going over the level cap. Which means that if the current level cap is 5, it can grind on its own, assuming that nothing goes wrong, and have all of its Pokemon at level 5. Or if the level cap is 50, then it can do that and all of its Pokemon are 50. No problem. Yeah, so that is fundamentally how it works. However, if the amount of actions you could take or you could possibly take is gigantic, then it's very hard to get much progress. Because yes, you do just essentially it's like an evolution style model where you run it even when it's just doing random things and it picks up on what random things are good. But if you have trillions of combinations of things that could be happening, it can be very hard to get a model that tries enough random things that eventually it actually catches on to what's going on. If there's so many different things that could happen and moves that could be done and enemy Pokemon and levels, etc., it's kind of hard for it to catch on. Yeah, so like it's potentially that instead of just hitting a local maximum, if you imagine it, instead of like being a really bumpy surface, it's really flat for a whole lot of the space, but basically just doing random moves, even if you do one other move, doesn't make any progress, then your improvement doesn't ever actually head to a local minimum. So instead of it being a very, very bumpy space with lots of local minimum, it could be very, very, very smooth. So you just get stuck. No matter how many times you run it, because there's so many possible things, it never actually catches on. That's a risk. It's possible we won't face that. But that's where people run into problems. in these types of things. So, yeah, like we'll take this approach, and we'll be able to just kind of train it on these simpler battle AIs at first, but most of what we'll be doing is running it against those other AIs and letting it learn how to improve itself against them. Some simple things you can kind of hard code to tell it to do, or to take into consideration, but that's our idea. Yeah, so we need to construct our run, and then we also, yeah, like based off the wins and loses, it affects the next encounters. It affects your box. That maybe this time now you have a Tepig, and you have a Lillipup, for example. Your current box also affects which encounters are valid encounters, because you can't have two of the same one by Nuzlocke rules, or if you've ever had one of that same evolutionary line, you can't have any more, and so on and so forth. It's a very repetitive process, and since it's like all random, and there's a lot of back-to-back battles, it's possible what we'll see is that it fails after a certain point. Yeah, so that's one of the things that we can do after we've trained this model and are getting it working in its in a simulator. What it can do is it can we can write some code so that it's more human friendly. So instead of it just running thousands of runs at the same time, it's instead just running one run, which is the run, and we actually just listen to what it tells us to do, and I manually play Pokemon Black 2. So we would just have a prompt up of what it's saying the right move is, and I just follow that move. And then in order to deal with the other issues, like grinding or whatever, we just hack in rare candies or something. That way it doesn't have any EVs, we don't bias anything. And it can learn, and we can actually showcase it as playing Pokemon Black. You kind of get to skip over all of the actual coding something that can manually input the buttons by just having it be a display that says, hey, do this. And then you do it, tell it what happened, and then it tells you the next thing to do. And yeah, in that case, it would be able to get shiny Pokemon and all of that. We could also just manually tell it its encounter is shiny, just so that it's fun to show, but yeah. So I guess the next thing that we can do... I guess something else we'll have to consider as well is in Pokemon Black, there are ground shaking spots, which will have a different set of Pokemon that it can see. I'm pretty sure ground shaking spots start happening once you get a little bit more into the game, so it might not affect it too much, but we would need to add the idea of it going for a ground shaking spot as a different thing. Because you could get an Audino as a manual player by just running back and forth waiting for a ground shaking spot to then run into it. Yeah, we can find a map for what Pokemon are on what encounters, but we also want to know like the possible levels. Oh, that's something I didn't mention as well. That the way that levels work for wild encounters is generally that, let's say you have a 50% chance of getting a Patrat and a 50% chance of getting a Lillipup. If it's a Patrat, then you have a 33% chance of it being level 2, a 30 for 3, and a 30 for 4. So that would be something else we simulate. Yeah, so we can find a map, but the question is, do we want to manually enter in all of this information by looking at a map? Because that might take a couple of hours to like transform this into Excel if we do it manually. When we could also write some code that just goes to each route and pulls the information for us and constructs this. It might be overkill for what we're doing, but it is a possibility for us to do. That way, like, it can be kind of automated for other games as well. And this is basically a map that we clicked on a certain route, and it told us what Pokemon were there. Like, if we check in Nuvema Town, we see that there's a gift Pokemon there. Yeah. Like, so I will say, like, web scraping is not that hard. It's just really tedious. Because if you see, what is it? Inspect. This is what the actual, code for this website looks like. And we can see, like, the trainers that are here. Like, it says Bianca is there with Oshawott. And, like, so here it says Pokemon Trainer Bianca. It's not very zoomed in. And we can pull out what level they are. We can see, like, the class level inside of this Pokemon Trainer Bianca is level 5. So you can write some code that, given this, like, HTML, you do some sort of for loop to turn it into it. But all the web scraper is doing is you download this HTML for a website. You give it a website, you tell it to download the website as an HTML, and then you write some code that interprets this. And there's a ton of Python libraries that simplify this process for you. So, like, I wouldn't put yourself down. Don't think that you can't write it, but it's just really tedious at times, especially if their websites are in kind of an inconsistent format. Like, a website like Cerebi, I think, is probably a good thing. Like, they probably have a consistent format across all of their pages. But if this Nuvema Town format is different from the format of Nakreen City, then it might not be so easy. And at that point, if it's a bunch of different formats, it kind of makes sense to just manually do it yourself and make an Excel spreadsheet, spend a couple of hours, watch some YouTube, and do it. But yeah, so let's get started then. Yeah, exactly. Like, they probably use, like, a template that they make pages off of. But if there's, like, things you don't consider, like, you have to look at all the different pages to see what are all the different possible things that they could have in a page, etc. But yeah, so that's where we can get information, at least, to build the run. So the run, we know it can all be done from Cerebi. They're a great website. They've got all the stuff we know that we need, at least. They unfortunately don't have like EV, IV information about each Pokemon. But they do have at least the move sets and the abilities and the levels, which is probably enough for this first pass. And so if we want to make it easy on us, we just assume 0 EVs, 0 IVs. If we want to make it hard on us, we could assume all IVs are 31, and then do some sort of competitive nature and competitive EV spread, just so that it's as hard as possible instead. Depends on what we're feeling, but that's kind of a one way or the other thing, and it's for later on down the line. Yep, and then the other thing is we need to see like items, basically what items become available here, so that the team building AI knows what items it's allowed to give its Pokemon. For example, with what's a good example? Here we go. Yeah, Miracle Seed, Charcoal, Mystic Water. Some of these are conditional. It's you only get a Mirror Seed or Miracle Seed if you chose Snivy. So we need to take that into consideration when the team building part is happening, that it only gets Miracle Seed if you chose Snivy. And if you instead got Tepig, then it's Charcoal. Anytime where there's grinding, though, we'll just take the assumption that it's possible for it to do grinding perfectly and get as much money as it wants and level up as much as it wants. But it's just for items like this and berries and other things, we just have to check when it first becomes possible to get it. So there's the details about the run itself and where we can get this information. We'll just do in order every trainer that's required. For example, this Pokemon Trainer N is a required battle. We can even watch somebody else's playthrough of Pokemon Black as a Nuzlocke and find which trainers were required. Because generally, or any sort of speedrunner playing the game, because they'll only fight the required battles in order to do it fast. So that would be another way of us getting information about what battles happen. Okay. So continuing on, let's move on to the next thing that we need to actually build information about. So we've got information about the run, which I'm just going to go ahead and type building the run. And this one is just about the AI. Now we need to know how do we constrain the battles and what are we going to do about that. So based off of the trainer information from the run, that's how we can start doing the battles. What we're going to have to do is we're going to have our own AI face off against the enemy AI. And the differences are that our AI needs to be the good AI, needs to be like the reinforcement learning. And this is the goal, is to create a good AI that can beat the Nuzlocke. On the other hand, the enemy AI is something we also have to write. This should be directly related to the game. It should be true to the game. It should be challenging, but only where the game is challenging. It should match good and bad decisions. And this is our kind of main antagonist AI. So we want it to be as fair as possible, because if we just make it super simple, then when we go to do the real thing, basing it off of the real game, telling it what's going on, if we made our enemy AI too weak for our training, then our real AI probably won't actually be able to last against the enemy. So this needs to be as true to the game as possible, making good decisions when the enemy AI would make good decisions, bad decisions when it would make bad, and just match it as closely as possible. Then our AI will actually be trained against all kinds of AI, because we want to train it to be as good as possible. So during the run, it's just this. We limit it only to this. But during training, it will be our AI facing off against any opponent AI. That way it can learn all sorts of things, like what happens when they do random moves, what happens when they do the strongest move possible at each point, what happens if they just switch constantly. We can make 10 different kinds of opponent AI, ranging from smart AI, like enemy AI, manual improvements on the enemy AI, random choices, different kinds of hard programmed AI, so that it gets to see all different kinds of things. This also lets us score it against the others, because we can simulate 1,000 battles between each of the different kinds of AI and see who comes out on top most. And if our AI is coming out on top the most, then we can feel confident that it's doing well, and it will be good inside the actual run. of course, inside the actual run, all that matters is the head-to-head between our AI and the real enemy AI. But during training, we want to take any improvement we can get. So why limit ourselves artificially? Okay, so that's our goal. Now that we've kind of got everything spoken and planned out, our next steps will actually be to start building up this information. So if you're watching on YouTube, stay tuned. In part 2 of this video series, we'll be doing the actual research and building up of our data set. We'll be talking about the different ways that we can store that data, how to process it, read it in Python, get the information out. And this will kind of set the groundwork for all the AI that we can do. If instead you're watching on the VOD after the fact, or you're watching right now, that's what we're going to do right after this. But otherwise, if you're on YouTube, thank you for watching. Please consider liking and subscribing. It would really help me out. I'm just starting this for the very first time, so I'm sure I've made tons of different mistakes. But either way, please check out the channel. I've got all sorts of links in the descriptions, Twitter, Twitch, YouTube. I've got a blog, everything. So thanks for watching, and until next time. Okay, now that I've done that, the outro's already done for the YouTube video, I can continue on with this. So, where we left off last time in the YouTube, and just 2 seconds ago on Twitch, if you're not on the Twitch, check it out. We do live streams Tuesdays and Thursdays. Is that we planned out how everything was going to work, both during training and during the run. And the main thing that we established is that we need to build up this database of what the run will look like. All the valid encounters, the valid items, what trainers happen one after the other, etc. Because without that, we can't actually simulate an AI playing Pokemon Black. So that's what we need to do. As for how to do it, we can use websites like this one that's open on the left side of the screen. This is Cerebi.net. It will let us see on every single route what all the encounters are with their odds and possible levels. And we can pull that information directly from there. We can also then see what are the battles that are required and use those as our reference for the run. So there are a couple of different ways that we can do this. What will likely be making the most sense is a JSON object, where a JSON object is it originally comes from JavaScript. It's like JavaScript object notation or something like that. Don't quote me on that. And what we're going to do is we're going to store every battle in a JSON object or a CSV, depending on the format. We might save it in both, just so it's convenient. It will be in order from start to finish. The trainer one will have each trainer battle. It'll be assigned an ID, the trainer name, which Pokemon they have, what all their abilities are, and move sets, and EVs and IVs, and everything. So that way, we can just load in that and treat that as the truth. So then, if we want to switch gears and instead of doing Pokemon Black, we do Pokemon White, we just alter it where we need to alter it, if anywhere, and it's the runs for Pokemon White. And then for Pokemon Black 2, we just change the trainer list, do it all over again for the trainer battles, and our same code will work once again. So let's get started on just doing this grunt work to create the run. We'll probably go ahead and just do it in Excel. This is the not so glamorous part of AI that like you don't see too much in tutorial videos, and it's building your own data. It's a very real part of AI as a job, that sometimes you don't have perfectly formatted, wonderful data. Now, in this case, we could build some sort of web scraping tool to try to tell us, okay, like scrape out the trainers and the trainer information and what Pokemon they have and what move sets they know, but that will likely only work for one kind of page. And once you start doing it on a different kind of page, then it breaks, and so you'd have to write different code for every single different game. Whereas we just want to have one format per project that anybody can easily do. So that's exactly what we're going to do. I'm going to go ahead and zoom in on the spreadsheet so that it's clearer. And here's what we want to keep. We want to do something like a trainer ID, which is going to be, let's call this a battle ID. We're going to have the trainer name. We're going to do the Pokemon 1. We're going to do Pokemon 2. Or I guess we need to do more details about the Pokemon 1. Then we're going to do more details. So let's look at the very first route, or not very first route, very first town in the game, because that's where our very first battle is, which is Pokemon Trainer Bianca. So this is going to be battle ID 1A. So let's do, let's call this 0001A. This is Pokemon Trainer Bianca. We're saving the name just because then we can print out like who is battling at this current moment in the run. Maybe do some sort of visual information. That would be neat. And other things like that. Pokemon 1 is an Oshawott. Pokemon 1 gender is going to be female. We also need Pokemon 1 level is 5. We need Pokemon 1. We don't need the type, because that we can just look up based off of the Pokemon name. But we do need the ability, because Pokemon can have different abilities. So this is Torrent. We also need Pokemon 1 Attack 1 is Tackle. Pokemon 1 Attack 2 is Tail Whip. So on and so forth. Attack 3 is just going to be empty. Attack 4 is also going to be empty. Pokemon 1 held, or we'll just say item, is going to be again empty. And then, is there anything else we need to know? I guess if we wanted to actually do the EVs and IVs from real data, if we had it, we would want fields for EVs and IVs. This might not be important for this game because I believe from the research I've done, Pokemon battles in Pokemon Black do not have EVs or IVs. If I'm wrong about that, please let me know in the chat or in the comment section if you're watching this on YouTube so that I can account for it. But from everywhere I've tried to find it, I haven't been able to find information about that. So I don't know if it's just that they don't have it, if it's just random, or what's going on. But if I can find it, then I'll absolutely add support for it. Otherwise, I'm just going to assume either worst case scenario, they're all perfect IVs and a competitive EV set, or best case scenario, we'll just set them all to 0, and then the AI has the easiest time dealing with it. Either way, not sure, but for now, I'm going to leave them out, and it'll be simple enough to just add them in as new columns if they're there. So, these are the different kinds of information we need to know about each Pokemon. Is the gender, level, ability, attack 1, 2, 3, 4, and held item. So then we can do this again, but now instead of Pokemon 1, it's Pokemon 2. And if it's none, then it just means that there isn't one. So this is going to lead to a lot of columns because a trainer can have up to 6 Pokemon. And that, with all of their different moves, up to 4 moves and a held item, it leads to a lot of columns. But at the very least, once this data is done, it's very, very easy to read it when processing it with Python. You can just use a library called Pandas, which is really good for reading Excel spreadsheets and CSVs into Python, and it's very interpretable. Each row is a battle. It has an ID. The reason why we did 1001A is because there are different branches, whether you choose Snivy, Tepig, or Oshawott. So we can kind of identify them as different things. But this makes sense from a interpretability standpoint, even if it is very verbose and with lots of potentially empty space to work with. So let's... That's Pokemon 3. That's Pokemon 4. Pokemon 5. And Pokemon 6. So now we've got columns for each of our different values. Just to kind of show, we'll select all of these, open up a new sheet, and we're going to paste it transposed. And we can also zoom in. So battle ID, trainer name, Pokemon 1, several columns, Pokemon 2, several columns, Pokemon 3, a bunch of columns. Oops. Yeah, there we go. Pokemon 4, so on and so forth. Pokemon 5. And lastly, Pokemon 6. There we go. Didn't take too long. So now we've got all of the different columns that we want. We can just cut those. And paste it, transpose. Yeah, there we go. So there's all of our different columns. So this is Pokemon Trainer Battle ID 001A. So now if we did 0001B, this again has Pokemon Trainer Bianca, but instead of having an Oshawott, she has a Snivy, also female, also level 5, with Overgrow, with Tackle and Leer. And then 001C is Pokemon Trainer Bianca with Tepig, female, 5, Blaze, Tackle, and Tail Whip. So those are all the first battle. Based off of a branch, you'll do one of these 3. Then, immediately following Bianca, you have a second rival fight in Pokemon Black and White. So we'll do 0002A. A, B, and C. This is going to be Pokemon Trainer Sharon. And instead of having a Oshawott Snivy Tepig, it's a Tepig Oshawott Snivy. They're all male. They're all level 5. And then Tepig has Blaze, Oshawott has Torrent, and Snivy has Overgrow. Their first move is all tackle. And then their second move is Tail Whip, Leer. So we've now stored in our table the first 2 battles with all the different branches that they could possibly have, based off of it being you choose Snivy, Tepig, or Oshawott, and again for Snivy, Tepig, or Oshawott. So you can see that if you pick Snivy, Bianca will pick the one that's weak to Snivy, whereas Sharon will pick the one that is super effective to Snivy. These battles down here do not happen right away. In fact, I believe these are post-game battles. So for just creating a run where it goes to an end, we'll never actually need to incorporate these battles. But you can see that we would do Pokemon 1 equals Stoutland, and then Pokemon 2 is Simisear with all of these different abilities, and etc. For now, because of the fact that we're using Showdown to simulate it, and Showdown does not allow items to be used, we are also not allowing our enemy AI to use items. This is a little bit of an oversight because we might end up weakening the trainer AI because they don't get to use items. And so we might be training a model that only is good against a weaker form of the real AI. But hopefully that will be balanced out by the other factors that we're considering, and our AI will still be able to handle it in the real game. It's just an unfortunate side effect of the fact that we're using Showdown, and we're not building our own from-scratch Pokemon Battle Simulator. So we take the good with the bad. Alright, let's just go ahead and to get one more, because it's probably a good idea to get one more. We should label the next battle as well. That way we just have 3 battles, and we can load in those 3 battles in order. So we can kind of show what it's looking like from a Python data structures point of view. So after leaving that town, you go to Unova, which has some, or you go to Route 1, which has some wild encounters, and it has no trainer battles on the main route. This is out on the branch because you can surf to the left. So let's go to Route 2. Actually, let's go back to Poke Earth Unova. So there was Route 1. After Route 1 is Accumula Town, which right whenever you enter Accumula Town, there is a Pokemon battle against Pokemon Trainer N. So let's say 0003. 0003. I want these all to be text. Let's just go ahead and do this general as text, and then we'll make this 0003. There we go. As Pokemon Trainer N, with his male Purloin. Oh, that pasted a link. Really? Is it just gonna do that? There we go. There's Purloin, which is male, level 7. And then has Limber, Scratch, Growl, and Assist. with no held item and nothing else in there. So this is going to be storing all of our battles, but as we had talked about before with the whiteboard, let me go back with the run, that the run is not all just battles. There's also team building components based off of the available items and the available Pokemon to encounter. For now, this table is just going to be the battles, storing each battle ID. So we're doing this in order and labeling each battle in order, but in order to actually structure the run, instead it's going to be you do battle 001A, then you unlock, and then you do battle 002A with no unlocks in between because they're back-to-back battles. Then you unlock these encounters, these items. You do team building for battle 0003. Then you do battle 0003. So on and so forth. Each of those unlocks will also unlock a new level cap, potentially. It'll either be the same level cap as what we have right now, or it'll be a new level cap. The level cap will be the level of the next gym leader's highest level Pokemon. And in the case of the Elite Four and N and Getsus, it will be, for the Elite Four battles, the level of the highest leveled Elite Four member. And then for the N/Getsus fight, it will be the level of Getsus's highest level Pokemon for the team building phases. But we'll again do that once we're actually constructing the run out of these different data sets. So for now, we just continue on. N is the only trainer that you have to fight inside of Accumula Town. And after you do that, then you can move on to the next town. So let's go back to Poke-Earth. After Accumula Town, you can go to Route 2. It has another set of encounters, and then let's see the trainers. There is Youngster Jimmy, Lass Molly, Youngster Roland, Bianca, and then that's it. But what we're not sure of is which are the required trainers. So we're going to have to check that by looking at the actual map of the route and see which trainers are unavoidable. When in doubt, we'll just add them all and assume that they're all required. But if we can, we want to find just which ones are required so that we're not adding extra work for us. But for just a little bit, I'm going to take maybe like a 5-minute break, and then I'll be back. So stay tuned, and we'll continue in just creating probably up to the first gym in this data set, so that this is enough to play around with. And our first primary goal with all of the things that we're doing is just training an AI that can beat the first gym, following the rules that we've set out over this past hour and a half. So thank you guys for watching for now. I'm going to take a quick break, and I'll be right back after that. And we're back. Just had dinner. It was a Japanese dish called nikajaga, homemade. It was really, really good. And now I am energized and ready to stream for the next 3 hours doing this database stuff and getting started with this project in earnest. Checking on the stream, making sure everything's all good. Still recording. Everything's great. We're live. Alright. So, where we left off, we were just saying that we wanted to at least fill out the battles up to the first gym. That way we can really say for sure, here's at least the first gym. Is our stuff working up to that point? Can we load everything up to the first gym? Because once we get that, then really that's just enough to kind of prove the concept. It's a proof of concept. In the industry, you really start every single project you do just by making a proof of concept, which is a very minimally viable way of showing that what you want to do is even possible. And our goal in mind, our end project, is an AI that can create or can run through an entire game following the Nuzlocke rules. But in order to have that, we need to show that we can have an AI that can beat the first gym. It's relevant to what we're trying to do. It's directly transferable. Once we get it working to the first gym, then it's just some modifications and some improvements to get it all the way. And there's nothing fundamentally different about training an AI to solve the first gym and training an AI to beat the whole game. The only difference is complexity and difficulty. And that's not... we're not reinventing the wheel to go from the first gym to the whole game. So that's why, at least for today's stream, that's what we'll stick to, is the first gym, all the required trainers up to there. And for now, we can simplify it after the fact. We're going to assume every trainer is mandatory on this route. We can double check our efforts afterwards and remove the ones that aren't. We can even add some sort of identifier that it's an optional one to the ID. But for now, we'll just continue our work. So trainers on Route 2, we've got 3 of them. Oh, 4 of them actually, because Bianca's there. So we're going to have more rows. So here's 0004, 0005, 0006, and then 0007, A, B, and Z. We've got Pokemon Trainer Bianca for each of those. We've got Youngster Jimmy, Lass Molly, and Youngster, not Jimmy, but Youngster Roland. Youngster Jimmy's got a Patrat. Lass Molly has a Purloin. And Youngster Roland has a Lillipup. Male, female, male. All these are level 7. Runaway, Limber, and Vital Spirit. Attack 1 is Tackle, Leer, Bite, Scratch, Growl, Assist, and then Leer, Tackle, and Odor, Sleuth. There we go. So there's our attacks. Now Pokemon Trainer Bianca. This is our first enemy trainer that's got 2 Pokemon actually. So Trainer A, again, it's if you picked... we need to be careful. Yeah, we need to make sure that everything lines up. So A is going to be when you choose Snivy. So in this case, 007A is going to be when you choose Snivy, and it's this one. We've got a Lillipup. No matter what, they have a Lillipup. That Lillipup is always female. That little pup is always level 6. Always has Vital Spirit. And then always has the same moves. Leer. Tackle and Odor Sleuth. But then they also have a Pokemon 2. The first one has an Oshawott. The second one has a Snivy. And the third one has a Tepig. All of these ones are female, female, female. All of them are level 7. The Oshawott has Torrent. The Snivy has Overgrow. And the Tepig has Blaze. Attack 1 is tackles across the board. Attack 2 is Tail Whip. Leer and Tail Whip. And now these 3 Pokemon also have an attack 3. Water Gun. Vine Whip. And Ember. And none of the Pokemon have held items. So there we go. So now we've got another round of Pokemon done. Up to Pokemon Trainer Bianca, which is the last trainer on this route for Pokemon Black and White. There are more items, but we'll go back up to the map. And we are getting close to our goal. That was Route 2, and now now Strighton City, which is the city with the very first gym. In Strighton City, you have to battle Pokemon Trainer Sharon, and then the first gym, which has each of these trainers. So what we're going to do is add more trainers. We'll have to check to see, can we go to that other route before fighting in this. In the Dream Yard, you have more wild Pokemon, ground shaking spots, swarms, legendary Pokemon, gift Pokemon. We'll have to check the order of events for these Team Plasma Grunts, but I believe right now the Team Plasma Grunts are after you beat the gym. But just to do it, let's look up a walkthrough. Let's look up Pokemon Black walkthrough. Okay, yes, we can go over there. And once we come back, then we fight Sharon. And then we can challenge the gym. And the gym trainers are mandatory as well. After you beat the first gym, that's whenever you go over and fight Team Plasma. Okay, so there we go. So we'll go ahead and add those other trainers as required trainers inside of the other area, the Dream Yard. But other than that, we won't add the Team Plasma grunts yet. And that will give us the last bit of trainers that we need. So the trainers, Last Airy and Youngster Joey. So 0008 is going to be Last Airy. 0009 is going to be Youngster Joey. And then 0010, A, B, and C are going to be the Sharon rival fight. 0011 is going to be the first gym battle. 0012 is going to be the second gym battle. And then we have 0013, A, B, and C, which are the 3 different gym leaders depending on the Pokemon you chose. And these are all of the trainer battles that you can face up to the first gym. We can then, even if they're not necessary, just skip them once we're constructing the run. That way, we don't have to throw things out. And if we want to create something that can fight every single trainer, or even give it the option to fight optional trainers, if it wants, that's something we can still do. But these battles are everything we need to get the first gym badge. So we have Last Airy, Youngster Joey, and then this is Pokemon Trainer Sharon. And then these are going to be the gym battles. So if we go to Striking City, gym, Waiter Maxwell, Waitress Tia, and then leader, Chili, Silent, and Cress. Chili, Silent, and Cress. There we go. So those are the names. Now we just have to, again, just follow through and add each Pokemon where they're needed into the spreadsheet. So this trainer has 2 Purloins. And then that one has a Patrat, has 3 Patrats. Both of these are female, and the first Patrat is male. Level 8 with Limber, Scratch, Growl, and Assist. And she seems to have identical Purloins, so we can just copy this whole thing and in Pokemon 2 paste it. So now her 2 Purloins are done, and she is done. And then he seems to have 2 identical Patrats. So both level 7 with Runaway, Tackle, Leer, and Bite. And that's all the information about one of these Patrats. Then we go into Pokemon 2, paste it, and then he is our first opponent to have 3 Pokemon. So in Pokemon 3, we are going to put Lillipup, level, or male, level 7, with Vital Spirit, who has Leer, Tackle, Odor, Sleuth, and that's it. Okay, so those 2 trainers are done. Pokemon Trainer Sharon is inside the city. He is, if we go to trainers, right here. So he's got either a Tepig, an Oshawott, or a Snivy, based off of your choice, as per the usual. They're all male. They're all level 8. Blaze, Torrent, and Overgrow. Pokemon 1 attack 1 is always Tackle. Pokemon attack 2 is Tail Whip for the first two. And then Leer. Attack 3 is Ember. Ooh, and this is our first held item Pokemon as well. Ember, Water, Gun, and Vine Whip. And each of them have an Oran Berry. Their Pokemon 2 is the same for each. So Purloin, we'll just fill out the details for each and then drag down. Level 8 with Unburden, Scratch, Growl, and Assist, with no held item. So Purloin, Male, there we go. There is Sharon, Oshawott, and Snivy. Or Sharon with his Tepig, Oshawott, and Snivy as the different options. Alright, and now on to the next one, which is the gym. Which these are all still single battles as well. Forget that in one of the ROM hacks there's there are triple battles or rotation battles instead, which is something we'll have to deal with at some point, unless we try to ignore them, but that might not be a wise decision. Alright, Waitress Maxwell just has a Lillipup, which is male, level 11. Waitress Tia has a Patrat, which is female, and level 10. The Lillipup has Vital Spirit, Leer, Tackle, Odor, Sleuth, and Bite. Our first one with a 4. And then the first Patrat has Runaway, Tackle, Leer, Bite, and Bide. They are both not holding any items. She has a Pokemon 2, which is Purloin, which is female, 10, with Limber, Scratch, Growl, Assist, and Sand attack. Alright, and then lastly, our gym leaders, which are Leader Chili, Leader Silent, and Leader Cress, each with 2 Pokemon. The first one is always a Lillipup that has the same moveset and same details, so we'll just copy that one. Lillipup, 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 always male, always level 12, always with Vital Spirit, with Bite, then Work Up, then Odor Sleuth, then Helping Hand, with no held item. Then their second Pokemon is Where Things Change. This is a Panseer, a Pansage, and a Panpour. All male. All level 14. All with the ability Gluttony. With the ability Incinerate, Vine Whip, and Water Gun. Then for second skills, they all have workup. For third skills, they all have lick. And for fourth attacks, they all have fury swipes. And that's all of the battles up to the very first gym. Obviously, this can continue just by copy-pasting and following along with Cerebi. But this is a good stopping point to get our trainers and start loading them into Python and see what we can actually start doing with this information, rather than just copying it down and saving it to a file. Okay, so let's save this to location. Let's save this to like the data folder. And we're going to save this as our Pokemon Black run. There we go. Pokemon Black run. So this is our information so far about all the trainers. This can be edited more in the future, but this is our trainers. Next, what we need to do is the actual items and encounters. So let's do encounters next, because that's more of a fun one. So what we'll do is we'll have maybe something like encounter ID. We'll have the Pokemon. We'll have the level range. Let's go to the very beginning, which is New Vema Town. Let's say, instead of just encounter ID, let's do something like encounter area ID. Or like area ID. Area name. And then we'll have encounter ID, because we'll have multiple encounters per area. We don't so much care about all the different battles and grouping them by area, but we do care about the different encounters and grouping them by area, because you can only have one encounter per area. So we have to enforce that. So we're going to have encounter ID, and we'll have encounter Pokemon. This is going to be like the name of the Pokemon. So our very first set, our area ID, is going to be, and let's change this to text so it's just easier to deal with, 0001. The area name is New Vema Town. Yep. And then there will be encounter 001. Let's change this also to text. So this is encounter 001. The encounter Pokemon will be Snivy. We'll have the odds, which in this case we will set to I guess 0.3, or maybe 1/3. I guess we shouldn't do 1/3. Perhaps let's just do 0.3. Zero 0.3. Just 1.3. Now it's equal to 3, 3, 3, 3. That's fine. Okay, so the odds is 0, 3. The level range is just going to be 5. If we want to just make it easier on ourselves in the future, we can do 5 to 5. This needs to be text 5 to 5. These are all going to be numbers. So 5 to 5. The reason why we wrote it this way is because we want to actually support a range of levels, so that you could have a minimum level to a maximum level. That way we can just kind of play the odds. And writing it in this way just means we don't have to have a special case where there's just one number. Simple enough. So that's all the information we really need per encounter. And then we paste again, but this time instead of encounter D001, we have tipping, which has again the same odds. And then paste again with encounter ID 003, which is Oshawott. So these are the 3 different encounters you could possibly get in New Fama Town, because you have to get this Pokemon. So even if there are technically wild Pokemon that you could get in some other way from this place, this counts as your encounter. So these are your gift Pokemon, and it counts as the Pokemon for this route. Okay, moving on into Route 1. The encounters you could get here. So this is area 0002, which is Route 1. Encounter 001 is going to be a Patrat with odds 0.5. And the level range is 2 to 4. And because you can't surf, and you'll have to go and get Pokemon from this, we will just go ahead and say that this is your only 2 encounters, is Patrat and Lillipup. Route 1, we'll change this to 002. Instead of Patrat, there's also a chance of getting a Lillipup. Odds are, again, 50 with a level range of 2 to 4. Alright, the next place is Accumula Town. Are there any Pokemon that we can get? I don't think so, because these are trades, and those don't apply. But there are plenty of items, so we'll do those later. None of them are items that do anything whenever you give it to a Pokemon, though, so we can actually just ignore all of these items. As for these, items black and white. Just Pokeball, again, that's just an item that something can hold. These also don't do anything. So items are actually pretty easy for these first few towns. There's very few items that become opened up. So Accumula Town, there's no encounters here. So there's nothing to do. We just move on. On to Route 2. Route 2 has 3 different encounters you could get. We're, again, ignoring the ground-shaking spots and swarm Pokemon. So what we'll do is we'll have 0003 is Route 2. Encounter 1 is Patrat with 0.4 odds with the range 4 to 7. Zero 02, 003, Lillipup, and Purloin. 0.4 and 0.2. This has the level range of 4 to 5 or 4 to 7, and this one has 4 to 5. Alright, so there's our encounters for Route 2. We're almost done with encounters. Striaton City. For Pokemon, just has some surfing and fishing spots, which again, we don't have the rod yet, so we can't get any of them. So we can safely ignore all of those encounters. And there's no gift Pokemon either. So we are perfectly good to just skip it, then move on. And the last place you can get an encounter before fighting the gym is the Dream Yard. Actually, I think maybe you can go to the next route over, but just to the entryway of Route 3. I'll have to check. I think it's just swimming, though. I don't think you can actually catch any Pokemon. But for now, we'll leave it alone. Okay. Yeah, so for now, we'll leave it alone. It doesn't matter if this information is perfectly accurate. We're just trying to get the gist so that we know what to do. Okay. So for the Dream Yard, the wild encounters, it can either be one of these, Patrat, Purloin, or Munna, or we could also have it get one of the Pokemon, Pansage, Pansear, or Panpour. So we've come to a crossroads a little bit in how we want to deal with this. Since I'm the one that makes the rules, because I'm doing it, I can choose for it to be as simple as possible, right? So the simplest thing would be to count gift Pokemon as exclusive to the route, meaning that you don't count them as your encounter. But I think since we want to account them as the encounter, the best way of dealing with this is to instead just let it randomly choose. Either it's going to go for a traditional encounter, one of those three available, or it's going to choose one of those. So what we'll do is instead of doing like odds, or instead of just doing both and treating them as separate encounters, we will just multiply the odds of each of the actual individual Pokemon, which are these three, by half, and then treat Pansage, Pansear, and Panpour as 50% odds. Since they are distinct encounters, they only apply under certain circumstances. We can have them each have 50% odds because they can't happen at the same way. So what we'll do is area 0004 is the Dream Yard, which has, and then encounter ID 1 is going to be the Patrat. Encounter ID 2 is going to be the Purloin. Encounter ID 3 is the Munna. These are going to be equal to 0.4 times 0.5, 0.4 times 0.2, or no, 0.5, and 0.2 times 0.5. The level is 8 to 11, 8 to 11, 8 to 11, and this is 002, 003, then 004A, because the first one is if you choose Snivy. Oh wait, no. Okay, so 004A is Panpour. 004B is if you choose Tepig, then it's Pansage. And then 004C is if you choose Oshawott, which is Pansear. We want to be consistent in our ID schemes. And the odds of each of these are going to be 0.5. And the level is just 10. 10. Alright, so these are all the encounters you could possibly get So you could get 4 encounters before the first gym. A team of 4. So assuming our AI doesn't kill off any of its Pokemon in these battles, we want it to be able to have a team of 4 going into that first gym fight. So now we've got the trainers and the encounters. Let's deal with the... you know what? Since there's not really any useful items up to the first gym, let's just not do any held items right now. Because I don't believe there are really anything useful. Items in black and white, there's still no held items that you could possibly hold that would be good. And then if we check some of the other routes, in like deeper in there are some held items like a twisted spoon, but that's deeper in there. Like we can check Strighton City as well for items. Yeah, fresh water and a TM once you defeat them, so that's perfectly fine. Accumula Town, any useful items? Doesn't seem like it. To hold. You'd have to show Kricketot, and oh, that's in Black, White, and 2. Yep. Route 1, any useful items? Personberry. Yeah, so I think for this first pass of just creating an AI that can beat the first gym, we'll just ignore any held items because there's just really not anything that you would hold. There are items that you could buy, and so maybe the AI should have the option, but none of them will do anything in battle. So I think it's safe to just skip for now, because none of this does anything for us inside of a battle. Okay, so we've got all of the trainers up to the first gym. We've got all of the encounters up to the first gym. And for now, we're skipping items. We'll just go ahead and create that sheet so it's there with something like group ID, group name, item ID, item name. The point of this will just be we can group some items together where if you beat this battle, you unlock this group of items. And if you go to this it's just if you beat this battle, you unlock this group of items because now you can get there. Okay, but for now we're just going to have 0 items so that we don't deal with it at all. So we've got our trainers, we've got our encounters, we've got our items. That's everything about the run, which from whenever we first built out our plan, that was everything that we needed to build the run, is that we need to have a team building phase when we're prepping for the next battle, that the AI will see the next battle, so the AI will be fed 1 row out of this information. I guess really the team building phase first takes place here, because these 2 battles are back to back and there's no chance to team build. So here, it'll be fed this information. Specifically, rather than the ID and the name, it'll just be fed here on, which is the information about the Pokemon. It will then get from the encounters which encounters are valid encounters up till now. It'll do the random draws. So for encounter area ID 1, it'll do this 33% draw to find out which starter it's getting. For Route 1, which is area ID 2, it'll do this draw to see which encounter it gets. And then Route 2 is after that battle. So let's load this into Python. So what we can do is we can open up this Pokémon Nuzlocke AI. This is just a template repository that I've put together with just some very basic code, and it just installs some of the libraries that are needed. All of the code for this project is pushed to my GitHub, which the link is in the description if this is a YouTube video, and I have all the links on my channel as well on Twitch if you're watching live. So you can follow along right then and there as well. And after every stream, I'll also push it to GitHub as well. But what we're going to do is we're just going to write a very simple script that can load in this data. So this is kind of a Pokémon Nuzlocke AI repository. And we're also going to open up Atom, which is my code editor of choice. So let's do that. Okay, so here we are with Adam opened up with our code. So this is just a simple test case that I was doing before, just to make sure that connecting to Pokemon Showdown was working on my local machine, creating just a very simple max damage player. In fact, let's go ahead and switch the view. There we go. That should be a little bit more clear what's going on, a little bit more zoomed in. And then let's continue on. So this max damage player right here is just selecting what is the highest base power move and then using it. So again, not a very sophisticated AI, but this is one example of the different AI that we will train our reinforcement learning AI against. Because any sort of good AI should be able to beat this max damage player no matter what. And we can create increasingly difficult AI using rules that will give a challenge to it. So this is just running some battles with each other, but let's create a new file, which is just going to be we'll call it runloading.py. So this is going to import pandas as PD. This is just a very simple way of loading in Excel spreadsheet data and CSV data into a very manageable format in Python. We're going to just write a function that will load the run data from a spreadsheet, given a file path, which is a string. And this is going to, let's just say from typing import list and tuple. This is going to return a triple of data frames, which is going to be the battles in order, the encounters, and the items. So what we can do is we're going to say battle df is equal to pd.read excel fpath sheet name is equal to trainers. We can copy paste this again. Encounter df is equal to pd.readexcel, the same file, but instead of trainers, it's going to be encounters. And then lastly, item df is going to be pd.readexcel, that same path, but instead of encounters, it's going to be items. I guess the last thing that we actually need is connecting the battles to other encounters and items. So let's just go ahead and add that as one last sheet. And we'll call this sheet run. So the run is going to do this very simple thing. Let's zoom in. What's going on? Why won't it let me zoom in? There we go. So what we're going to do is we're going to list which things are doing what. So battle ID, which will just say start for what you have access to at the start. This should be a text field. We can see trainers have battle ID. So 0002 will unlock a couple of things. It will unlock encounter ID, item ID. We'll add multiple things that it can unlock. So 002, that is the battle with Sharon, which is the second rival fight, unlocks these two encounters. Or no, sorry, just this encounter, 0002. So battle ID 0002 unlocks encounter ID 002, which this also needs to be text. Actually, let's just go ahead and say 002A, and that way we don't have to write any fancy code because we're doing this exhaustively. So basically, all three of these fights, whether you fight Sharon with a Tepig, Sharon with an Oshawott, or Sharon with a Snivy, that will unlock this encounter. From the start, you'll have access to this encounter, which is your starter. Since we're not doing items, we're just leaving items out. Then, the battle with N, which is 0003, unlocks encounter 0003 and encounter 0004. This is a little bit confusing, but it'll make sense with Python, and it's what lets us connect things together. And so that's all we want to say about the encounters, because you can do, after you've... oh, actually, we need to get to this area. So it's actually these three that unlocked encounter 3. Or encounter 4. It's basically what's your last battle before you can catch those Pokemon. So, since 0004, encounter 0004 is in the Dream Yard, you need to beat all the trainers on Route 2 and Route 1. And this is all we need to know for the first things, because sure enough, there are 4 encounters. Trainer 3, which is N, is the thing that prevents you from going on to the next route. Trainer 7 ABC is the thing that prevents you from going on to the next city, which is the Dream Yard, and lets you catch these encounters. Okay, so now we've got information, and this is just going to also give one more data frame, which is going to be our run df, which is pd.read Excel fpath sheet name equals run. Yep. And if you'll notice, the way that we've set everything up with these sheets, it means that it does not need to be an Excel spreadsheet. We could actually store this stuff in like a SQL table and have some sort of web page where you can edit these runs and save them as like a new table in the database and make it very customizable. We're setting ourselves up by not hard coding this to be able to expand this to any game that we want to do with any set of encounters, or even ROM hacks by just modifying what the encounter Pokemon are and how many there are. This sets us up to be able to do that very easily. It's a very manual job, but it's very customizable, and it means that we don't need to change anything about how our AI works in order to be able to do this. So that's that, and let's move on to back to running the code. So this is going to return all 4 of these data frames. So let's return run df, battle df, encounter df, and item df. And now let's just, for the fun of it, let's just run it and see what it will give us. So let's say if name equals name is equal to load run data by giving it data slash Let's see. Pokemon Black run. .xlsx. Print run df.head. Oh, we need to install Pandas. OpenPyXL, XRD, and let's just go ahead and install Jupyter as well. Jupyter notebooks tend to be a more visual way of showing this, so let's do that as well. Libraries are almost installed, and we'll be able to see all the run data that we just created here. So far, it will lead us to the first gym, and so we'll want to print out just all this information that we wrote, see how we can kind of merge it together, and we can really start loading in like showdown teams based off of these encounters. That'll be the next step, is for each of these trainers, transforming this format, which was just an easy and convenient way for us to take note, into actual Pokemon Showdown teams, so that we can create like simulated AIs that use those teams. Okay, so that is working. Let's try running it again. And we can see that in the run ID, it's printing out, it's a little bit small, but it's printing out the battle ID, the encounter ID, and then the item ID. And we can see that run is exactly those columns: battle ID, encounter ID, and item ID. This is how we're linking the events that happen to what encounter they unlock for you. That way the AI will just start battling each battle in order and unlock more encounters. For now, we're going to have it do every single exhaustive battle in order to beat the game. And we can simplify it and make the job easier for the AI by reducing that down to just the required battles. We'll have some sort of like required list, and we'll just have the list of which battles have to happen in order to do it. Additionally, for now, the way that we're doing the starter split is we have ABC at the end of our IDs for if you choose Snivy, Oshawott, or Snivy, Tepig, or Oshawott. So that's our data. That's really simple. Let's create some showdown teams out of it. We're using the library PokeEnv, which already has a lot of the kind of like Pokemon related data and Pokemon related scripting already handled for us. So that has libraries where we can just give it some information about a Pokemon, and it will convert it into the right format for Pokemon Showdown. So the way that we do that is we need to do this. So we can say from PokeEnv dot team builder dot team builder Pokemon import team builder Pokemon. Okay, it actually has lowercase b. Team builder Pokemon. This is an object that we can use to load in our information about a Pokemon and then print it out as in Pokemon Showdown format. So hopefully very soon we'll actually have a very visual way of showing this stuff. And hopefully that'll be more appealing to the eye rather than just looking at code. Okay, so the way that we use this team builder is we just need to pass in the information about the Pokemon. So we will do such that. So let's say for encounter, or no, for trainer ID in battle df dot index, or actually just for in index. We've got our battle ID stuff. Let's I'm just gonna save this over to the side so I know what I'm typing. All right. So we're going to say battle ID is equal to battle df dot locate index battle ID. Let's just copy paste this for all the different fields that we want. Trainer name is trainer name. All right, and then we have all the Pokemon related ones. So Pokemon name, or we'll say species 1 is equal to battledf.locate Pokemon 1. And then in addition to species, we also will need item. Item 1 is equal to Pokemon 1 item. On top of item, we also need ability. So ability. Let's actually just get rid of the ones for simplicity's sake. Pokemon 1 item. Then we need the moves. Moves is equal to Pokemon 1 attack 1 2 3 4. P equals 1. Let's just replace this with a variable so that we don't have to do so much stuff later. Ability. There we go. So there's all the moves and then the ability. And that's, oh, gender. We also need gender. Gender is equal to Pokemon 1 gender. Level. Level. Okay, so we've got Pokemon, gender, level, ability, attack 1, 2, 3, 4, and item. So now what we can do is we can write a loop to do this. So we can say for p in range 1 to 7 because it's exclusive. It won't go to 7. It'll go to the one right before 7, which is 6. We'll do this. We'll say if species equals np.man. Continue. Basically, if there's no Pokemon in that slot, just move on. Or actually, you know what? Let's just move on. Or break out. That's just more efficient. And now we'll say TB Pokemon is going to be equal to Team Builder Pokemon. And we need to pass in all this information. So the species is going to be the species. The item will be the item. The ability will be the ability. The moves will be the moves. For now, we're just passing in none for nature, none for EVs. The gender will be the gender. I believe whenever you pass a none, it might be random, but we'll have to see. The level is equal to the level. And that's it. Team builder Pokemon. And let's say let's keep a list of team. Let's say team.append TB Pokemon. So if we append those Pokemon onto the list, what we can then do is we can create a team builder based off of this thing. So let's import another thing, which is from team builder. We're going to import team builder. And we're going to say showdown team is equal to team builder dot join team, which will take a list of those team builder Pokemon, which is exactly team. And then we will print trainer name, let's say battle ID, trainer name. Let's print a bunch of hyphens. Then we have battle ID, trainer name. Then we're going to print showdown team. And then we're going to print this one. Let's see if this works. Ooh, cannot import team builder. Oh, it's team builder dot team builder. Okay. NP is not defined. Oh. Pokemon 4 item. Key error. Did I misspell it? Pokemon 3 item. Oh, I forgot Pokemon 4 item in my Excel spreadsheet. Pokemon 4 item. Pokemon 5 item. And Pokemon 6 item. Yep, I just forgot the column Pokemon 4 item. Float is not iterable. Ooh. Let's see. It's inside of the join team. I think probably there's some like empty Pokemon getting added, because none of the teams had 4 Pokemon. So that's my guess, and I think it's probably in here. If string species is equal to string name dot trim or dot strip dot lower float object is not iterable. This is what happens when you use other people's code. You've got to figure it out and why it's breaking. But we'll see why it's breaking in just a little bit. So let's see what TB Pokemon dot like formatted is, because maybe it's just giving us a problem. Not formatted. Float object is not iterable. Yeah, so I think we're appending some nans somewhere. So let's see what is going on here. So let's print out the species item and stuff like that. Ability, moves, gender, and level. Item, ability, moves, gender, and level. Oshawott, Nan for item. Torrent, tackle. Oh, I think I know what's going on. It's with the item. So what we need to do is, if it is Nan, replace it with none. So we'll say none if is an A, else. This is really not the right way of doing this, but I think it will work. What we're doing is, if it's a nan value, we're replacing it with none so that it's will be a little bit better. And then gender, level, and ability and species should always not be none. Let's see if that helped. Oh, string attribute has no. Let's do that. Dot lower equals nan. There's probably an easier way of checking that, but we write bad code here. We write really bad code here. Ugh, this is gross. There's so many better ways of doing this. But screw it. I just want something working. Okay, so now it's saying none type is not iterable. That's fine, I guess. We're getting a different error. But at least now it's like Oshawott, no item, torrent, etc. Let's dig into the code a little bit and see in their code, why is it breaking? So let's check in their GitHub. So what I'm going to do is I'm going to go to github.com and I'm going to pull up their one, which is Pokenv. Inside of Pokenv, Team Builder Pokemon, whenever we create it, we're setting the item. Okay, so this is just directly setting a bunch of stuff. Nickname equals nickname, etc. If Eevees is not none, then they're doing that. if moves is not none, etc. Okay. Dot formatted is then going to say self.prepare for formatting. Inside self.prepare for formatting, there's issues. So let's check prepare for formatting. For move in moves, move equals 2 ID string move. And it's failing in this 2 ID string. Let's see, 2 ID string is inside of pokeenv.utils. Pokeenv.utils ID string is from Pokeenv.data. Pokeenv.data. 2 ID string is joining each char dot lower together. I do not know why they are doing this. That's really weird. But I now know what the problem is. So we have been able to find out what the problem is by checking the actual source code. It's joining character for character in character.isAlphanumeric, alnum, dot lower. What we are doing is whenever we don't have a move, we're passing in none. None is not iterable. That's what this error message is meaning, is that we can't go through each character in none, because none is not a list. None is not a string. It's not anything that we can do that with. So what we really need to do is actually just not pass it in at all. Reduce down the list moves to, instead of being tackle, tail whip, none, none, to just be tackle, tail whip and end right there. So we can do that. We can just say something like moves is equal to m for m in moves if m is not none. And now let's check it out. M is not defined. Oh, oops. Typo. There we go. Okay, so that worked. Let's get rid of all this print stuff, so because it's clogging up everything, and let's get rid of this because it's clogging up stuff. Okay, so this is printing every trainer in Showdown format, which has, we have the ID, we have the trainer name, and then we have the condensed formatted like Showdown ID of the team. It's showing each of the Pokemon, the ability, and then extra information about it, which is great because that's a format that Showdown can deal with whenever we're trying to give it a team. So let's do this in a real way. Let's check out like running this in Showdown so we can see what one of these teams looks like. For now, I'm going to be doing everything in my local version of Showdown. That way I'm not messing around with the real Pokemon Showdown. I don't know what their policies are with bot accounts and bot teams and simulated battles. And so I think it's probably best to not try to find out and instead just run it locally because it's open source code. We can do that. So in order to launch it, we just have to run node Pokemon Showdown start. And for now, we are doing it with no security on our own local host. That way, we can send as many requests per second as we want to it, and it will not rate limit us. So we can train models off of this Showdown server because each model can give hundreds of requests per second, and the Pokemon battles can take like literally less than a second because both players are AI, so they can send responses back and forth super fast. So we've got our Pokemon Showdown server set up. And now what we want to do is we want to check and see if it's up. So let's do local host. I think I did 8192. So here we go. Here is our Pokemon Showdown server with like our locally hosted backend. It will have the same front end as the real Pokemon Showdown website, and we can see if we go to watch a battle. There's no battles going on right now. Let's see if we can't find like a replay. And right now, I want to see if we can find where we find like all the battles that have happened. If we can watch some battles that have happened. Past gens, OU. So far, we've been doing like Gen 5 stuff. Gen 5 singles doing Ubers. There are no battles going on right now. Oh, but what we can do, actually, let's run, instead of running our current code, which is the code that just generated some teams, let's run the original simple test code that I wrote, which will actually use this Pokemon Showdown server. So by doing this, we can run simple test.py. We go back. Let's see, refresh. There should be games going on right now. All formats. Oh, here we go. We can see battles that are actually going on. These are just AI players going against each other. In this case, this is two random players going back to back. Let's see if we can just mute this for now. This is two random players playing. They are at each turn just selecting a random move, and not really caring what's going on in the battle or what the type of the opposing Pokemon is, or anything clever at all. Our goal is to create better and better rule-based AI. You can see that actually all the battles have finished. This is just as fast as Pokemon Showdown, the website, will go. Both players were inputting their moves as fast as possible, and the game was actually going on really fast in the background. But it's just still updating exactly what's going on right now. We can also actually play against one of the AI players using this library as well. But for now, these are just all AI opponents. They're doing Gen 5 random battles, which is a randomly assigned team, so not Nuzlocke compliant at all, or realistic teams based off of what you'd have in an actual Nuzlocke. But for now, it serves as a good starting point without having to dig into effort of giving them real teams. And we can confirm that everything's working. Also, it's covered up by my cam, but let me move this up here just a little bit. This is actually the results of the kind of bracket that we just ran, which was two random players and two max damage players. These max damage players would just find the move that is the highest base power and use it. Different moves have different amounts of base power, and they'll just pick randomly from the moves that are, if there's a tie of base power, and use it. We can see from the bracket that maximum damage players won against random opponents about 90% of the time, which makes sense because a random opponent just doing whatever things, even if it's not effective, can lead to a very long battle. So we can see this battle's going on like almost 50 turns because they're just not really doing anything. And it's possible that Vigoroth has nothing that really affects the opponent. They have Toxic, and Vigoroth could use Toxic, but it's still not because it's just using random moves. So it's likely that random player 2 is going to win this, just because Vigoroth is not taking into account that Giratina is immune to normal and fighting type attacks. And sure enough, random player 2 won the battle, but there was no effort in there. It was just random moves. And there we go. That's all the battles that have happened, and that's everything. Now let's actually create some AIs that are going to be using the teams that we just did. And we can even play against them and have them challenge us. So let's go back for a second. Let's see, can I oh, close that. Close that. I would like to log in. Home. I'm going to do a Gen 5 random battle. Say Volander. Choose name. And so right now there's no authentication going on. So I'm pretty sure Volander is just already somebody else's account. I didn't just steal somebody else's account. It's just that there's no authentication going on because everything's just running on this local server. So apologies to whoever has the account named Volander because it did just say it already existed. But I just logged in with your account on my own local server because no checks are actually being done. I can't see any of your stuff or whoever's this stuff is. I can only see what's on my own local server, which is not that type of thing. We can also see, okay, this is the actual global replays. So we'll have to find another way of watching already existing battles between AIs. But now I'm logged in under the name Volander. Oh, wrong password. Let's choose another. Volander AI. Not. There we go. Now I'm there under Volander AI. Let's copy paste some of this code. In fact, I'm just going to do a random player. Random players. So what we'll do is we'll say teams. Let's go. Teams is equal to an empty list. We're going to append this showdown team onto the list. And then after all those teams are built, we're going to have a bunch of random players. One for each of those teams. It's going to be a random player with, up to 20 concurrent battles. Sure, why not? The battle format is going to be Gen 5 Ubers. None of these Pokemon are Ubers, but Ubers is very unrestrictive on the rule set. So we can, it's very free for us to just use whatever. I do want to see what other rule sets we might be able to do so that anything can go. But for now, we'll just stick with Ubers, which means some of these might not work because they have duplicate Pokemon. But yeah, so we have random players for team and teams. Then lastly, we need to tell each random player what team to use. They're just going to use a specific team. So whenever we create the random player, we're going to give it a team, battle format, log level, save replays. There we go. It's just team. Team equals team. And then we're going to say let's have one of them challenge myself. And the battle format is still Gen 5 Ubers. Or, you know what, let's just have them play each other. That's another easy thing to watch, and it'll be clearer what's going on. And we can find out, of those trainers so far, which one is the best. At random battles, right? Okay, Gen 5 Ubers, await that, and then this is going to be, I need to make an asynchronous function. In order to call this, async def main. Main, and I'm going to pass in all of this information. And all of this is going to go inside of our main function. There we go. So now we can call asynchronous functions and have no problems with Python. And then we also just need to import async IO. And random player. Alright, so let's try this again, but instead of doing what we just did, which was a bunch of random teams with 4 different kinds of players, we're going to do a bunch of different kinds, or different teams, all random, facing off against each other. One last thing, just because I think it would be kind of neat to do, is attach their name as the kind of thing to go by. So what we'll do is we'll say something like names dot append this. This is going to be their name in Pokemon Showdown, is Battle ID trainer, so that it's unique. And then we go here and say names equals empty list. And for team, name in zip teams names. And we want to name each of these random players. So let's name each of these random players. We need to give a player configuration. Which is just a tuple of name and password. All right, so now let's, instead of running simple test, let's run loading and see if this works. Ooh. I forgot to set these as arguments for main. server config is not defined. Ah, I need to copy some other things. So that it knows which showdown to try to play on. We have to actually import player configuration so that we can give these guys usernames. It's just for the showiness of having them have usernames. If it doesn't work, we'll just give up. But I think it'll work now. Okay, let's check things that are going on right now. Watch a battle. Refresh. Oh, your name must be 18 characters or shorter. So let's just slice it to the first 18 characters. Oh, name taken. Your authentication token was invalid. But we don't want to do... Alright, I guess for now, let's give up on giving them names. I think it's okay. It would be kind of neat to be able to have them have names, but I think it's a little bit more of a headache than it's worth right now, just for the sake of running this demo. Oh, it doesn't like us having exactly 0 EVs. Huh. That's weird. It tries to protect you by telling you that your Pokemon must have at least 1 EV. In that case, let's just go ahead and say EVs equals 1 for each thing. EVs equals 1, 1, 1, 1, 1, 1. And let's set IVs equals to 0, 0, 0, 0, 0, 0. Or, you know, let's set them all to 1, 2. That way, in case it gives us the same error that it just gave us for EVs, we'll just have already got it covered. Let's see if now it will work. We're just fighting with Showdown to get everything up and running. Oh, there's battles going on. Okay, yeah. So here, this battle already ended. It was a very fast battle. And some battles are getting rejected because you're limited to only 1 of each Pokemon due to the species clause. So this was a battle between random player 1 and random player 10. One has a Lillipup and one has an Oshawott. And you can see these are real teams of real trainers in the Nuzlocke. Random player 1 would be, according to our Excel spreadsheet of trainers, it would be Pokemon trainer Bianca with an Oshawott. So the very first level 5 Oshawott. And it seems to beat random trainer 10, which is 1, 2, 3, 4, 5, 6, 7, 10. Which is, let's see, Lillipup, well, it might be going out of order. I think it might be going out of order because of something else that's going on. But he just had a level 7 Lillipup and nothing else. So that's youngster. Oh wait, no, never mind. It was right there. I just missed it. Youngster Roland on like Route 2 with just a level 7 Lilliput. So we can see our trainers. However, we are getting an issue because in even in Ubers, you're only allowed to have one of each Pokemon. So it rejected random player 14, which in this case is Lass Airy, who's on route, or who's in like the Dream Yard, because her team has 2 Purloins that are both just exact copies of each other. So this is something that we need to figure out, because our battle simulator is playing by competitive Pokemon rules, which limit the kinds of Pokemon you have to just one of each species, one of each held item, etc. So what we would like to see is there a format of Pokemon Showdown that like anything is fine for that. Like, I wonder if this anything goes has exactly that, but let's check by kind of like, you know, doing some research. Anything goes. Let's see what anything goes is. Species clause is lifted. Okay, so this sounds like exactly what we want. Now, I don't know if anything goes has a Gen 5 variant. Let's see. It does have an anything goes thing. So let's see. Are these all of the formats? Gen 5 overused for past gen. Gen 5 random battle. Gen 6 pure Hackmons. Gen 5 overused. Pokemon Showdown. Gen 5. Anything. We would like to have we would like to have Gen 5 anything goes specifically, because then it'll be by Gen 5 mechanics, and we won't have to worry about any of the updated battle mechanics that have happened since each version of Pokemon. If we can't do that, then we might have to pick something like Gen 7 anything goes. If there is a Gen 6 anything goes, we would do that. We would just try to pick whichever one that we can that is the closest to that generation. National Dex anything goes. That's also a Gen 8 one. I don't know what the difference is between National Dex anything goes and just anything goes, but Pokemon Showdown Gen 5 anything goes. We'll keep looking for it. There seems to be replays for it. Let's see if it'll show up as a valid one if we do Gen 5 anything goes. We can just test it. There's no reason why we can't. Your selected format is invalid. Darn. Okay, so it seems like it does not want us to do that. I guess we can try Gen 8 anything goes. Or Gen 7. Let's try Gen 7 anything goes. Okay, it seems to be running. Yep, and here we go. Here's battles going, and since it's anything goes, everything is perfectly fine. Yeah, so there's a lot of battles going on at once, and these battles happen very, very quickly. The whole battle will be like done in like a couple of seconds. So this is a battle between random player 1 and random player 13, which is, according to our spreadsheets, Pokemon trainer Bianca, the very first battle with her, where she has an Oshawott, against Pokemon trainer Bianca, where she has a Lillipup and a Tepig. So after you refight her. Let's close back out and find a new one. Oop, there's a lot of warnings right now. It did not like the move Assist, but I think it's okay. Instant replay. Yeah, so this was between, again, Bianca and random player 15, which is Patrat Lillipup, which is youngster Joey, who has 2 Patrats and a Lillipup. So you can see that it's just running basically a series of battles in between each player. All right, now it's running 20 battles at a time, which we might want to bump that up and see if it can go faster. And it's doing 100 battles between each trainer. So this will figure out which is the best trainer, following just this very simple random player out of all of them. This is kind of just a side thing. This is not really something we care about. But it shows us that at least our teams are being read. They're being imported into Showdown, and they're working as expected. We can see the battles are happening. All the different battles between random player 3 and random player 10 are happening. We can see the instant replays. And it's very easy to see what's going on. It's nice to see that it's actually working now, so that's very good. Alright, so since we know that it's working, we can go ahead and stop that now. This will just cancel all of the AIs that were running battles. They're probably just going to time out and give up. Because as you can see, it's just waiting for players now. So there's the Gen 7 Anything Goes. Ideally, we could try to find a way of doing Gen 5 Anything Goes, because that'll be by Gen 5 mechanics. But it's working. Alright, so that's a functioning trainer reading database. We can now load in any sort of list of trainers and actually have their teams working in Pokemon Showdown, as shown right then and there. If you're watching on the YouTube, then this is the end of part 2 of this series, where we develop a Pokemon battling AI to go through Nuzlocks. We've gone from just having the concept and planning it out to actually loading in teams into something that can be simulating battles between them. We've just chosen a very, very simple approach to trainer AI, but in the next video, which on Twitch will be just right after this, we'll be developing more sophisticated trainer AIs so that we can closer simulate the real AI that you would face if you were playing the game. Once we get that, and we have a couple of different versions of the trainer AI, from very simple complexity to more higher complexity, we'll again repeat this battle of all of the trainers facing us against everything, so we can validate that later trainers are, of course, coming out on top, and weaker trainers are coming out on bottom. And we can then watch through and make sure that some of the battles made sense, that they were picking moves that were super effective and were making the use out of the strong trainers. And that when a strong trainer with a strong AI faced off against a strong trainer with a weak AI, the strong AI won. So that's coming up if you're watching on Twitch. If you're not watching on Twitch, consider stopping by. I stream on Tuesdays and Thursdays. Right now, with our current set of projects, Tuesday is Pokemon Day, where we'll be working on this Pokemon training AI. And Thursdays is Cocktail Day, where we'll be working on a cocktail creation AI, an AI bartender, if you will. So stick around. Also, I'll be uploading each of these individual parts to the YouTube channel, one by one, as we're building out this project. And once the project's finished, we'll be putting it all together into one big video. It's more of an entertainment factor to show what we've done, and try it out in real Pokemon Showdown and real Nuzlocke to see if we can get a Pokemon Nuzlocke beating AI. So thanks for watching, and I'll see you next time. Okay, so we can pick up again on the stream. Welcome back. Where we left off last time on the YouTube was we just got some trainers loading in to Pokemon Showdown from the actual Excel spreadsheet of Pokemon trainers from Pokemon Black. We are making this Pokemon Excel spreadsheet ourselves so that we can fully control the format and fully adjust what's going into it. But of course, we can spend more time in the future automating this process so it's not nearly as hair-pulling. But next, we want to create a baseline enemy AI. This is not going to involve machine learning, and instead we're going to try to replicate the type of AI that you would see in the actual game. This is going to be somewhat challenging, but it's not something we have to worry about perfecting. It's just something that we want close enough where it feels like you're going against the real thing. This is because we're going to train our actual Pokemon playing AI off of this simulated AI and not the real game. The real game would be much too difficult to try to run millions of instances of. So this will give us the ability to simulate everything much, much faster and train AI much, much faster. So stick around and we'll be working on that right after this. Okay, so what we need to do, last time we just tried out things on Showdown, and now we're going to go back into the AI side of things. So before we had this script that could just load in some teams and create teams. Let's separate this out as a separate function. What we're going to do is we're going to say build teams. This is going to take in as information the run DF and actually just the battle DF is all it's going to take in as information. And it's going to return out a list of strings, which are Pokemon Showdown teams. So let's just copy paste all this stuff from there. Okay, so now we have a function that can, given a data frame, return a bunch of Pokemon Showdown correct format teams, so that we can use them in creating some other AIs. Then all we have to do here is we just say teams is equal to create teams, or build teams, and pass in the battle DF. And now our code is back to where we just had it a second ago. Let's start by creating some AI. So what we're going to do is we're going to create a new folder in our code. Let's call this trainer AI. And in here, we're going to create a couple of new files. So we're going to create a max damage, or a best move, or I'll say high power. We'll create a high power AI. It'll just choose the highest power move. So slightly better than randomly choosing a move. We're going to make a best move AI. So it will do the best damaging move, taking into consideration things like same type attack bonus, the weaknesses of the opposing Pokemon, etc. Then we're going to do one that is supposed to be a simple switching AI whenever it's worried about it being damaged. So it's going to be the switch best move. So this is going to be similar to the best move AI, but whenever it is determining a move, if there's another Pokemon that it has that can have a better move to use, it will switch to that Pokemon first and then use its best move. And lastly, the one that we'll try to do is we'll try to do like the actual game AI. And this will be us trying to mimic as close as possible what the game does. This gives us a big range of different kinds of AIs to do, and we can verify, is the game AI beating these other ones or not, and are we being a good faith effort to the game AI. In all of these, what we need to do is we need to go from Pokémon import player, because each of these are going to be building off of the player class, which Pokémon provides us. This is the library that we're using to build up off of. And actually, in a previous test, I already did this max damage approach, or high power approach. I called it max damage before, but now what we're going to call it is high power. So if a player can attack, it will. It will, out of the battle's available moves, it will choose. It will say that the best move is the one that has the maximum base power, and it will use that move. This is a very simple AI. It's not doing anything complicated, but it's doing that. So now let's do something based off of the best actual move. So from this, we need to inspect this battle object. This battle object has all of the information about the actual battle. High power, before, we were just pulling out the available moves from it, but it actually has a lot of different things about the battle, and we want to check out all the different things that it can give. So let's check that out. So inside the battle, we have the active Pokemon, a list of all the active Pokemon that we can get, called all active Pokemons. Let's check if we can get the opponent active Pokemon. Yeah, there we go. So if there are available moves, we will try to choose the one. Oh, we're editing the wrong one. If there are available moves, we're going to want the one that has the best damage on the Pokemon. So the opponent is going to be the opponent active Pokemon, or it's going to be battle opponent active Pokemon, which this will be a Pokemon object. A Pokemon object has an ability, base stats, boosts, which is a list of different stat increases, current HP, damage multiplier. Okay, so damage multiplier is exactly what we want. So what we're going to do is the best move is going to be out of the available moves. It's going to be the move dot base power times okay, let's put this all in parentheses. So it's going to be the move's base power times opponent dot damage multiplier and we're going to give it the move, which is this move. And then so this is checking how much we're going to damage the Pokemon based off of this move. And then let's check if we can do stab. Okay, so I don't think there's a built-in stab check, so we'll have to also do that. So we're checking opponent.damage multiplier, and then we also need to know the self types. So opponent and the player, or the current opponent Pokey. That's how we'll call them, opponent Pokey and current Pokey. The current Pokemon will be the battle.active Pokemon. And our stab multiplier what we'll do is do this. So max battle moves, key equals lambda move. It's move.base power times opponent.damage multiplier there we go, times 1.5 if move.type. Oh, yeah, let's check move to see what it's called. Yep, it's called type. If move.type is equal to current Poke.type times 1.5. Yeah, it's called type 1 and type 2 in case you have multiple types. Else 1.0 if current Poke.type 2 is not none and move.type is equal to current type 0. Else 1.0. Alright, so what we've done is we've taken the base power, we're multiplying it by how much it'll impact the opponent, and then we're multiplying it by 1.5 if the current Pokemon, if the type matches either of the current Pokemon's types. And so instead of high power, this is going to be best move. This still doesn't take into account the ability of the Pokemon. Some Pokemon's abilities will influence the damage and the power of their moves. So this could actually be expanded, but the point is that now we're using more information. Before, all we were checking was the power of the moves. We weren't caring anything about who we were using it on and what we were doing. But now, by checking the best move, this will actually solve the problem of we're not going to attack a ghost-type Pokemon with a normal move unless we only have that. In fact, if it's like going to hit a ghost type of Pokemon and it doesn't affect it, this damage multiplier will be 0, and so the whole effect will be 0. So it'll choose a different move, or it'll choose a random move. And so yeah, now that's good. Now what we need to do is move on to our switch best move. Where we want to check what can we do out of all of our Pokemon. So out of our current available moves, what we'll do is we'll find the best move for here. So the best move is going to be the maximum out of all of our different moves, based off of the like move base power. So what we want to beat is that base power, or the impact that it has. So in fact, let's stop doing this all in one line, and instead let's do this in more of a for loop so that it's a little bit more sustainable. In fact, let's make a helper function that will let us do this. So let's just do something like calc move, and it's going to take in a move, and it's going to take in current Poké, and it's going to take in opponent Poké. And what this is going to let us do is we're going to then determine what is the power of the move. So this is going to return some sort of float. So what we'll do is we will say something like power is going to be equal to move.base power. Power times equals opponent.damage multiplier. Opponent Poké.damage multiplier. Move power times equals this whole thing. And then also this whole thing. And then we'll return power. So now we'll say powers is equal to calc, let's say calc power. Calc power, move, current Poké, opponent Poké, for move in battle dot available moves. And so now we can simplify this whole best move nonsense by doing actually this. We'll make it a tuple, where this is going to be move power for each of these, and we'll say best move is equal to the max of powers by key equals lambda pair pair 1. Basically, we are looking at the second item of this tuple, the 1th place item of this tuple, to see what should be the maximum. So this will let us simplify the other one. Let's go ahead and copy this over here. But now we want to do a little bit better. So this is going to be the switch best move, where we're going to just switch to whatever thing can do the most. So it's not just enough for us to check our current active Pokemon, but we want to check all of our Pokemon. So let's see how we can do that. So we can check our all active Pokemons. Or we can do all of our available switches. So let's... Yes, if there's available moves, else we're just going to pick a random move. Yeah, so what we're going to do is we're going to say, yeah, current Poké equals this. So what we're going to do is we're actually going to say switch, which is just going to be 0. And we're going to do it based on number 2. And then we're going to go for switch Poke in battle.available switches. We will say for, let's check out that Pokemon and all their moves. They have every Pokemon has an attribute called moves. So for move in switch Poke.moves, enum, or for E in enumerate, we're going to say powers plus equals E plus 1, move, calc move, switch Poke, opponent Poke, for move in switch Poke.moves. Just dot moves, not dot available moves. So there we go. Now we're checking each of those, and we're going to be adding on more things. And we'll say that the best idea is going to be the max of all of those. We're going to say if best idea 0 is equal to 0, then we're just going to go ahead and create an order for doing the best move, which is best idea 1. Otherwise, we're going to create an order to switch to a different thing. So let's go back to the player attribute. Which we can give it a Pokemon order or a move. So we'll give it the Pokemon that we want to move to, which will be let's put a -1 there, and then just E there. So if it's a -1, then we want to stay. Otherwise, we want to do switching to battle.available switches best idea 0. So we're going to switch to that other Pokemon that has the better move. So this might not be the best approach, but what we're doing is we're thinking ahead more in terms of what other Pokemon we have. So maybe if we can't do a ton of damage right here, we're just going to switch to another Pokemon that can do more damage. And that might be a better idea than just sticking around and potentially losing this Pokemon. And then for game AI, we'll just leave that alone for now. And let's test out these current trainer AI against each other and see how they do. So let's go to simple test. What we're going to do is get rid of this max damage player. We're going to say from, let's do new file, init.py. From trainer AI, import best move player from best move, import best move player. Let's just copy paste this a bunch. From high power, import high power player. From switch best move, import switch best move player, and then we'll delete this one for now. Best move player, high power player, and switch best move. And now we'll say we want some random players. We'll just have one random player. And we'll just have one best move player. Being player. Let's just go ahead and put them all on the list. There's no need to do duplicates of each one. Unless we want to see how they do in head-to-head. Yeah, I guess we want to see how they do in head-to-head. So we'll have a random player, best move player, best move player. High power player, high power player, and switch best move player, switch best move player. So these are our players. Then for the cross gauntlet, we'll do, I guess, maybe 50 challenges. And the battle format will be Gen 5 random battles, because we're training for Gen 5, because we're wanting to beat Pokemon Black as a Nuzlocke. And then let's cross-evaluate, and we'll tabulate everything together and see how everything works. Our custom Pokemon Showdown lobby is still running. So let's say Python simple test.py. No module named best move. I need dots in front of each of these. There we go. Let's go to watch a battle, refresh. Oh, this format does not let you use your own team. Are they using teams for some reason? None of these should be using a team, so I'm not sure. Should these be... Let's copy and then Control Z a bunch just so I can get back to seeing the max damage player that I had from before. Yeah, it imported from player. Battle format equals battle format. Let's reboot our Pokemon Showdown custom server. Watch a battle, refresh. Okay, yeah, now we're not getting that issue. Yeah, so I guess it was just a weird one-off issue. Oh, tuple has no attribute species. Uh-oh, we're passing in something slightly wrong. And this was just random players against random players. Okay, so let's see. The issue was inside of... battle order, player. Best move player. And the issue is that tuple object has no attribute species. So in best move player, what are we doing? We're just picking the maximum power move. They're doing max battle.available moves, key equals move.base power. And now we're doing max of powers, key equals I know what it is. We need to pull out the move. We can't just give the tuple. We need to pull out the move. One unfortunate thing about this is that it will just fail and not stop on its own if it fails. So we have to keep rerunning it from scratch each time. Alright, let's go back home and let's see it refreshing. Okay, so here's a battle of random player versus high power player 1. And let's watch the whole replay. Oops, string. Okay, we'll check on this in a second. So this is let's switch sides. So the high power player is, let's see, yeah, choosing like hydro pump each time, it seems. Hydro pump, yep, because hydro pump is Starmie's strongest move. So it's just choosing to use the highest move it has each time, which is Hydro Pump, no matter what the opponent's resistances may be. Alright, so then we had another issue inside of, just while that's running, we can be debugging some stuff. We had this string attribute has no attribute base power. So we're passing in a string when we should be passing in like probably a move. And this was inside of switch best move. Okay. So we're saying power equals move.base power inside of calc power, but we ended up passing in a string instead of a move. Switch Poke.moves. We're saying for move in switch Poke.moves, move in current Poke.moves. Let's check the Pokemon object again and see. Moves is a dictionary of the Pokemon's known moves. Okay, so we actually need to say for move in, or we can just do for blank move in current Poke.items, which will pull out the current Poke.moves.items. Which will pull out the move, which is the value in each of those dictionaries. Okay, so let's try this again. At the very least, we can see that the high power player is doing better than random player because at least choosing the strongest move is better than just doing random nonsense. But now let's run it one more time. Let's go back home. Alright, and lots of battles are happening. There's like 63 battles all at the same time. Okay, so unfortunately, some of them are disabled whenever an opponent is using disable. So I think we do need to use available moves when you're currently in there. Because you can't use a move that's been disabled, and that's the point of having available moves versus moves. Let's go and check again. Let's watch a battle. Ooh. Gen 5 Pokemon has... Oh. Another typo. It's fine. At least it's an easy to diagnose typo. We can ignore these nature power things because it's just a warning, and it's just because nature power turns into a different move. It's just being ignored, and we can safely just move on. Okay, let's see. List has no attribute items. Okay, because this one's not a dictionary. Just minor things over and over and over again. But that's coding sometimes. Oh, I already know this is gonna fail. So there's more than 100 battles going on right now. Let's check out random player 2 versus best move player 2. Switch sides, do the instant replay. So random player just randomly switched. Swampert used Earthquake. Very good move. Random player switched. Swampert again used Earthquake. Sharpedo, but this player, ooh, I guess maybe Earthquake is doing the best because it's a high base power move times a stab. And we don't know what the rest of best players' Pokemons are. We don't know yet what the rest of best move players' Pokemon are, but we'll see soon. Okay. And now is it going to switch to a Pokemon with a higher base power? That'll be the test to see if this is working right. Okay, so it used Wish, which should have no base power. So we're confused at why it's doing that. Let's try to figure out. Best move, oh, is just using the one with the highest attack. This has Wish, Double Edge, and probably not much else. And it's faced off against a Ghost-type Pokemon, which is why it's just failing with its available moves. Skip to the end. Let's see. Yeah, okay. Also, the tabulated results are in for which AI was doing the best. It seems like out of the results, switch best move. So best move player had the best results. So just choosing the best move by taking into account stab and not switching to another Pokemon that had the best move seemed to have just slightly the best performance over switch best move. They seem to be pretty evenly matched though, with only about a 50-50 toss-up between these two types of AI. So this is still very simplistic AI. It's just random move, picking the highest base power move, which we can see still got crushed by the switch best move and the best move. Picking the best move, taking into consideration the opponent's typing and your own typing. And then switch best move, where you look across all of your Pokemon and you see which one of them can do the most damage, and you switch to that Pokemon. And otherwise, if you are that Pokemon, you use the move. So, best move player so far is our best AI. But we're still just trying to replicate that. Oh, how do I calculate this value? So in this case, this value is literally simulations, the head-to-head score of these different AI. So we ran, let me check, 50 battles between each AI. And there were 2 copies of each AI. That way we could get some head-to-head results of the same AI against the same AI. And these numbers are what percentage of time the one on the left beat the one on top. So we can interpret this single 0.96 as best move player 2 beat random player 1 96% of the time. So this will actually give us real head-to-head results of how our model is doing. Right now, we're still just trying to create some rule-based AI so that we have something to fight against when we're training our reinforcement learning model. And we just simulated 50 challenges between, 8 different players. So 50 times 8, like 400 battles in less than a minute. So we'll be able to really train some good models in this by also making the maximum concurrent battles even higher for each of these models, or for each of these trainer AI. Yeah, so now the next thing is we want to start in our actual game AI class. This is meant to mimic as much as we can get it the actual trainer AI that you would face when playing Pokemon Black. So what we're going to do is we're going to... I found a page earlier that was about how AI worked in some of the ROM hacks by default, based off of the AI levels. And there are a couple of considerations that it takes into place. Now, everything is a little bit flexible of how much it can know and how much it can't know. But I think by starting from there, we can get a pretty good estimate of the actual trainer AI in the battle. So I think it was Pokemon Trainer AI. There was some page where we were talking about, or where they picked apart the ROM of one of the games and figured out how the trainer AI was working. Here we go. This is the page I found earlier. Okay, so what they covered in this Pokemon Battle AI overview is that the game AI takes the following steps. It decides whether it should use an item. Right now, since we're using Showdown to simulate our battles, we'll be skipping even trainer items. This is an unfortunate drawback because in the real Pokemon games, the enemy AI can use items, and that does make it more challenging for the player. But for now, since we are not going to make a full Pokemon simulator on our own, we'll just kind of take that as a needed sacrifice that hopefully whatever AI we create will be able to just handle the items, even if it's not trained on opponents that can use items. Which items can be game-breaking for a human player, but typically enemy players just use it whenever they're on low health, and it's not typically a game changer for the opponent to use an item. So I think it'll be okay, but if it really is making or breaking the model, we'll have to figure something out about using items for trainers. So we can basically skip that whole section that our AI is just not going to use items because it can't use items. So it now decides whether or not it should withdraw. So this takes into consideration how good the opposing Pokemon is against it, and then how good it can use against the opposing one, as well as its current health and toxic and perish state. Yeah, so the idea is earlier in the stream, we put together a list so far of just the trainers up to Gym 1. And our idea is that we will simulate in Showdown, in order to train the model and actually run it as a proof of concept, just a list of battles against the teams of every single trainer in series. The way that we'll kind of do things is we will have two different phases. We'll have a team building phase where there's a pool of Pokemon that are relevant to a Nuzlocke that you could have at this point in the game. It will team build out of the available Pokemon that it has in its box and its encounters so far. It will then simulate the battle with that trainer using the team that it built and the opposing team. And then, based off the results, if any Pokemon died, they're removed from the box, and they're no longer available to select for future team building, and it'll go on from there. So we're not training in AI to actually manually put in the inputs to the game to play it, but instead we're training the AI to basically do all of the team building and battling for us. So after we get it up and running, then what we can do is I can just manually play the game myself. And for every single battle, and right before every single battle, we will team build according to what the AI has told us to team build, following all the constraints of the Nuzlocke. And we will battle listening only to the AI and doing everything the AI tells us to do. So it's about as close as getting an AI to play Pokemon as we can without telling it to actually input every button press, which would be far, far more tedious to do, because we would probably hard code every single button press of moving around the map and all that. So for now, that's kind of our caveat, is that we are going to be simulating the whole process using Showdown, and then also asking what it will do in certain responses so I can follow along in a ROM, or a totally legitimate DS that's being streamed on the channel. But yeah, so that's the idea behind what we're doing. So far, we've loaded in manually some data using Cerebi.net. It's still open in some tabs. We've just written down basically the trainers up to the first gym. We could have done more, but it's just kind of tedious, and at least getting to the first gym is a milestone. So if we wanted it to go further, we just spend a couple more hours building out this spreadsheet. Yeah, so my idea for the AI part, I can kind of go over the idea. Oh, that's the wrong one. For the AI, there's kind of two parts to it. Let me get my face away from the visuals. There we go. Hopefully that's a little bit clearer. So there's kind of two parts. There is the team building AI, which could be a couple of different approaches. We could use reinforcement learning, or it could just be a simple constraint optimization style machine learning approach. It kind of fits for it to be reinforcement learning because we can actually then score how well the team it chose based off of how well the battle went. And then there's also the battling. Oh, yeah, thanks for the compliment about the overlays. These are actually just themes that you can choose if you get Streamlabs. I got everything set up over the past couple of days, and I'm getting used to it a little bit. So if anything looks slightly wonky on one of my overlays, let me know and I'll try to fix it. But for now, I think it's been looking nice. But yeah, so it'll be some sort of reinforcement learning approach most likely, because for our goal, we want it to actually, provide a team that scores really well in a battle, meaning we lose as few Pokemon as possible, and that kind of lends itself to reinforcement learning. So some sort of, neural network, deep Q learning approach will probably be the way to go. And then for battling is much more of an obvious choice for reinforcement learning. We've split it into kind of 2 steps. That way we can kind of have 2 different models training at once. And we can keep improving the team building aspect and debug that on its own. And then keep on improving the battling aspect and debug that on its own. In machine learning, you generally will see a lot of talk about not full stack machine learning, but full integration of machine learning, end-to-end deep learning. And that could be an approach that we take here. But the risk is that it becomes much harder to debug where things are going wrong in our model. That if we fail a battle, we would have to kind of dive deeper to see, is it because the team was bad? Or is it because the battle AI wasn't good? Did it have some idea that it was trying to do with the team, but it didn't really follow through? Like, it just becomes harder. But if we can kind of isolate them, then it'll be a lot easier to just get the team building part really, really solid and then never worry about it again. So that's the idea. Yeah, and so during the run, like our kind of run in quotation marks, it will be our AI against the game AI, as close to a faithful interpretation of the game AI as we can get. There's not an exact library out there that has already implemented the game AI exactly as it works, but we'll keep looking and we'll keep trying to modify it to get it to feel as close as possible, because we want to eventually test it out by manually running it on the game. And if we make it too easy for our AI during the simulated run, then it's going to be impossible on a real run. So that will be the goal, is that we will have our own AI that's reinforcement learning, whatever nonsense, against the enemy AI, which is a faithful reinterpretation of the AI that would actually show up in the game. And then during training, it'll just be our AI against any sort of opponent AI. Random, the best move, switching AI, and the faithful reinterpretation, our own AI again, everything else, so it can get as good as possible. So that's the idea. Let me know in the chat if you have any other questions or comments. Like, obviously this stream, it's just kind of a small stream with a couple of viewers, so I don't mind talking about whatever, answering any sort of questions. I, in my day job, work as a machine learning scientist here in Tokyo, where I am based. So I'm fairly familiar with a decent amount of actual implementation of AI kind of projects. And then in my free time this year, as a kind of a New Year's resolution, I'm going to be working on a bunch of different projects for AI, streaming the whole development process on Twitch, and then uploading excerpts to YouTube. Okay, so the next thing that we need to do is actually create this faithful reinterpretation of the enemy AI. So let's try to do that. So this is going to be Gen 5 AI player. And so the first step that it's going to do, ordinarily, choose an item needed. Yeah, so I'm actually leaving my current job and starting at a new one, so I'll tell you about the one I'm leaving, because that doesn't matter so much anymore. But I work in telecom right now. I'm moving to a completely different industry in AI, but that means I'm doing AI stuff for kind of subscribers to a cell network, specifically as it pertains to kind of customer experience. So anomaly detection of issues in the network for customers, complaint prediction, scoring the customer experience using machine learning to kind of do principal component analysis. And Also, one thing I'll say is just because a lot of people on the internet have this idea, the language you write in does not matter. People on the internet talk a lot about like Python being really slow or C being really fast or use this language, use that language. It doesn't matter. Like there are so many other things that matter more than the slight performance gain of a language. That really it's just whatever you're comfortable with and whatever the other people are comfortable with. But yeah, so I use Python and TensorFlow typically. Complaint prediction? It's like I guess it depends on what your target is. Like complaint prediction, ideally you're training a model that will predict actual complainers. But the accuracy of that is generally not very high because a lot of people will, even if they have terrible coverage, will not actually complain. Because maybe they don't want to bother. So instead of worrying so much about the accuracy, instead you just worry about, is this somebody who, if they were the type of person to complain, would complain? And if your model agrees with that kind of more subjective intuition, then it's a good model. So it's been kind of a weird shift where a lot of courses you learn about like accuracy and area under the curve and all sorts of rigorous ways of scoring models. Once you kind of get to industry, you find out that it does not matter what the number says whenever you're scoring a model. What matters is, does it agree with the gut feelings of domain experts? And does it provide something that you can explain the business use to executives? And if it does, then it does not matter the performance of the model. It just matters what you can justify. So I know that's kind of a vague answer, but that's been the biggest adjustment for me, is that you kind of have to start dealing with vague performance, where it's not necessarily bad performance, but you wouldn't call it quantifiably good performance, if that makes any sense. Like you start dealing with a lot of people who deal morally do more on gut feeling, and you need to train models that agree with that gut feeling. Okay, so we need to decide if we need to switch. That's the first part of the game AI, is deciding if we need to switch. And if it's not going to switch, then it needs to decide which move to use. So since it's not going to choose an item, we can just skip this. And now, according to this, it will decide whether it should switch by looking at a couple of different factors, such as how well the opposing Pokemon's moves will do against it, whether it can use any moves itself, and whether it's about to faint because of toxic poisoning or perish song. Okay, so if we do need to switch, then we have to decide which one to switch to. So I guess let's just start by doing something simple. So if we want to calculate the power of each of the opponent's moves against ourself. So what we can do is we can say for move in or let's say opponent Poke equals battle.opponent active Pokemon for move in opponent Poke dot moves. Also, we have to do moves to items. Okay. Oh, and I guess the other thing as well, if you're interested in machine learning as a career, or maybe you're already in it and you already know this, but I will say the job market, depending on where you are, is like crazy right now. because I started applying for outside things here in Tokyo, and like literally same day hearing back from places wanting to schedule interviews. So machine learning is crazy big right now, at least where I am in Tokyo. I think a lot of it's just because a lot of people in Japan don't do machine learning. So I've been able to take advantage of that, at least for finding a new job, which I've done recently. I'm starting in another month at a new place. Still here in Tokyo, but at least I'll be able to work from home more. Okay. So we're going to calculate the score. Yeah, like it was really a lot of postings about everything, and it was actually surprising. I don't know where you're at, but here in Tokyo, there's like no requirement to speak Japanese at all either for most tech jobs. So it was a very easy ability to find a job. Though right now, due to COVID, unless you're already in Japan, it's hard to get it from outside of Japan. So that's probably part of it, is that since I'm a English speaker already living in Japan, it was easy. It's not bad high-speed internet, even though I technically live outside of Tokyo, but like by like 15 minutes. It's like a train ride 15 minutes in, and I can be in Tokyo. I have like 2.5 gig internet for like $12 a month. So it's, there's some things that are really nice. But yeah, the borders are closed, so I haven't really been around Japan that much. You can technically travel wherever you want right now, but there's just that kind of that attitude of not traveling much. In actual Tokyo, like if you live in actual Tokyo, for like $20 a month, you can get 10 gig internet. It's crazy. They have super fast, just like customer grade internet. And I'm in like a suburb. All of my neighbors are old people, and I have 2.5 gig internet, and I'm actually streaming over Wi-Fi right now, so it's enough to be comfortable with that. Like the stream is, I think the quality of the stream is decent. I'm doing 1080p 60. I don't know if it's coming through in a good way, but yeah. So that's one good thing. I know that's probably not what you meant when you asked how do I like Tokyo, but hey, that's one good thing. But yeah, generally, the people are generally nice, and they'll try to understand what you're trying to say in Japanese, even if you can't really say it. And it's not hard to get around, even knowing just minimal Japanese. Like, I studied Japanese for a little bit, at least just enough to kind of read a little bit, and that's all you need. If you can read like katakana and hiragana, which are like two of the syllabaries or like alphabets of Japanese, then it's kind of enough to just get by, because then you can read menus, and you can read a lot of instructions on the back of microwave food and order at a restaurant and everything else like that. It also helps that my girlfriend here is half Japanese, so I can speak with her about that, and I can tell what's going on. Okay, so we're gonna calc power. Oh, thank you for the follow. Okay, so we're gonna calculate the power, except instead of doing current Poke, opponent Poke, we're gonna do opponent Poke, current Poke. We're flipping it because we want to know how well is the opponent's move going to work on us. And based off of that, we'll decide whether we want to move or not. So let's just go ahead and say powers is equal to move for move in opponent Poke dot moves dot moves Whew. Key equals lambda. So what I'm doing right now is I'm trying to calculate what's the biggest power move that can be used against it, and that's going to be like a score for what risk the current Pokemon's at. And based off that, we can kind of adjust it. Everything here in this walkthrough is kind of vague. So unfortunately, we're just going to have some sort of score that we have to kind of adjust to see if it's good or not. So key equals lambda pair 1. Oh wait, I don't even need to keep the move, because it doesn't matter what move it is, it just matters what the power is. Okay, so this is the max power, or this is opponent max power. And then we'll repeat it for own max power, which is just swapping these two. And then we can say something like, if it's gonna hit first, then maybe that's important. I guess for now, let's just say what we'll weight everything together later. We'll say owned or is faster is going to be current Poke. We have to go to check what our speed is. Current Poke.stats. It might just be speed, or it could be like SPD. I've got to check their code probably in order to see what it is. All right, we'll try speed. Otherwise, we'll do like SPD or something. Then let's check out what the like current HP is. Ah, that's a attribute. Okay, so we've taken into account a couple of these things, such as is it faster than the opponent? What's the opponent's max power move? What's its own max power move? Is this current Pokemon at risk? Is it on the third count of Perish Song? And there's probably plenty of other things that we could also try to check. Like, is it in toxic range? So like, is the next turn gonna kill it due to poison, etc. But for now, let's just kind of score this. So our kind of switch score is going to be some sort of combination of these different things, and if it's above a threshold, then it's going to switch. Or maybe if it's below a threshold, that way it's kind of easy to do. So switch score is going to be equal to 1.0 to start. If perishing, switch score times equals 0. Just if we're about to die because of Perish Song, then we just need to switch, so our switch score is going to be equal to 0. Otherwise, our switch score, let's see, how should we combine these things? Is equal to, or times equals, I wish I could see how they're actually calculating this, but I might have to download Pokemon Essentials and like rip out the code to see how they're doing it in Pokemon XP, or Pokemon like RPG Maker XP. Wait a second. Do they upload the whole script? It's an AI. So we might be able to kind of rip the algorithm from RPG Maker AI. Pokemon Battle AI. Okay, here we go. Dang it. This is just summarizing what we already knew. This is not the actual code. What we need to do is actually find the actual code so that we can kind of copy that algorithm in this. Let's look up AI. AI space. Okay, let's download RPG Maker Pokemon Essentials. not to make a Pokemon ROM, but to rip from a Pokemon ROM. Thanks to a DMCA notice, I have to find it in certain places, which means I have to move the browser over here and then search for it. That way I can search in certain places. Okay, there we go. I found a download for it. Ooh. Well, in the meantime, we'll keep moving on. We'll say if switch score is less than some threshold, like 0.1, we'll switch. So we'll keep editing game AI once I get RPG Maker Pokemon Essentials downloaded, and then we can copy that idea, because Pokemon Essentials, that's how the AI of some Pokemon ROM hacks work, because Pokemon Essentials is a kit that people who make ROM hacks, or not ROM hacks, but games from scratch actually, using Pokemon RPG Maker, or using RPG Maker XP with Pokemon Essentials. So the AI of how that works is probably good enough, because that's somebody else's approach to doing AI in Pokemon. And so it's probably good enough for us to kind of, rip and use for our own purposes. We'll have to dive in a little bit to try to find exactly where that script is, but I don't think it'll be too difficult. Alright, there we go. We've downloaded Pokemon Essentials, and now we just need to find where exactly the AI for where exactly the script for the AI is written. I might have to open some of this stuff up in RPG Maker XP. I already have RPG Maker XP, so it's not the biggest deal in the world. But that means it might be a little bit more of a time investment than we really want to do. So if we can just find some sort of simple script. Pokeball AI. Yeah, so we're gonna need to open this up in RPG Maker XP. So in that case, we'll save that for next time. That way I can get RPG Maker XP installed and play around with it a little bit next time on stream. Because I think it's probably not worth diving too deep into right now on potentially a wild goose chase. But this will give us, once we can figure it out, a very good way to just see somebody else's code implementation of AI, even if it's slightly different from ours, and implement it for ourselves. Is there anything else that we can really do until we do that? Yeah, there's plenty more we could do. So the actual way of doing a run is something that we need to do as well. So let's create a new folder. We'll create a couple new folders. We're going to create a new folder called Player AI to mimic our trainer AI. And we're going to create a new folder called Nuzlocke, as well as a new folder called Showdown. Nuzlocke will be for running Nuzlocks, and Showdown will be for doing things like challenging a player using our AI, and Showdown challenging the ladder, all sorts of stuff like that. Okay, so in Nuzlocke, we also will want to have a new file that's called run.py, which will be for a single run of doing a whole game back to back. And then I think that's it. That's all we need for there. And then we'll have a couple of files for in Showdown for ladder and demo. So in a Nuzlocke, what we'll want to do is we'll want to have one that loads data. Load run data, which we already did in here. Let's actually just copy paste both of these functions actually and put them in run. So these are some functions that we wrote earlier that will load the data for a certain run, all the Excel spreadsheets. And right now we're storing the data for a run like Pokemon Black into an Excel spreadsheet with 4 different sheets. It will build up all of the different trainer teams. And we also need to do something like get valid Pokemon. Oh, I know what we can do. We'll do this. We'll create a new file called box or encounter pool. .py. This is going to be a new class, encounter pool. A class to manage all of the encounters on a single run of a Nuzlocke. So that way, this will help us by holding all of the functions that we want to use in picking up a random Pokemon on each new route, in each new like area that we can encounter a Pokemon, as well as keeping track of which Pokemon have died based off of the status of battles, so that when the team builder AI is ready to team build, we'll just ask the encounter pool what are my valid encounters that I can use, and it will respond with that. So we'll want a function that can do something like add encounter, and we'll have something like self encounters or potential encounters, and it will add an encounter out of each potential encounter. It will get one and add it to the pool. Checking for species. Species and other limits. Automatically. In potential encounters. Counter.odds. All invalid. If encounter in self.pool, or if encounter not in self.pool, all invalid equals false. All invalid equals true. If encounter .id a in encounter.id, if self.limit mode equals a, all invalid equals false. Okay, so the idea here is that what we're going to do at a new encounter is check all of the potential encounters that we could have. So based off of our Excel spreadsheet of encounters, for a new one, like this route one, if Patrat is not in our own pool of already existing Pokemon, then it's going to be valid. So we set all invalid equal to false, and we're going to break out of this loop. So the point is that we're just checking, is there anything we can get? Because if there's nothing we can get out of this pool of encounters, then we're going to do nothing. And we're just going to end here. So if all invalid, return none. We're just not going to add any Pokemon to our pool because there's nothing here for us. Otherwise, we're going to pick a random one out of the available. So we're going to say something like... actually, let's not break because we want to keep track of which ones are valid. So valid encounters is equal to an empty list. And then we're going to just add it onto our valid encounters. So valid encounters dot append encounter. I guess we can just simplify our code a little bit. odds is going to be equal to encounter dot odds for encounter invalid encounters, and we want this to be a numpy array. So import numpy as np. We want everything to sum up to 1, and potentially that won't be the case because some of the Pokemon won't add up to 1. If we already have them. So like if we already have a Patrat, then in reality, in this route, we must get a Lillipup. So the odds will instead be 100. This is really simple. What we can do is we can say that odds is going to be equal to odds divided by odds.sum. Basically, if it already sums up to 1, then we're just going to be dividing by 1, and it won't do anything. But if it doesn't sum up by 1, in fact, if it sums up to like 0.5, then everything's going to be effectively doubled, so that the odds instead equal 1. So everything will just get scaled up accordingly and evenly to what we're wanting to do. This just makes it so that we can easily pick whatever thing that we want. And now we need to figure out how, which encounter we're going to randomly pull. So we need to pick a random number. That's really easy using numpy.random. So rand is going to be equal to numpy.random.rand. This just gives us a number 0 to 1. And as for which one it is, we're going to say for e odds in enumerate odds current odds is going to be equal to 0.0, or current odds is going to be equal to rand. So we're going to say if what should we do? If odds is greater than current, yeah, that's how we should do it. If odds is greater than current odds, we'll say greater than or equal to current odds, then we'll say current odds is equal to or current odds minus equals odds, and continue on. Yeah, so just what we're doing is just, we want to pick whichever item randomly. So odds is going to look like a list of like 0.2, or 0.2, if I can type, 0.5, 0.3. This is going to be some random number like 0.79. So what this is going to do is for each odds, we're going to say, hey, is this number greater than this number? If this number is not greater than this number, we're going to move on and say odds minus this. So now this is going to turn into 0.59. Oh, yeah, you're right. I should say odd. I'm tired. It's 11:36 my time, so I worked all day today, so I'm a little frazzled out, but thank you for that. Yeah. So it's going to be reduced by that, and then on the next step, again, it'll be reduced by 0.05, and it'll be now 0.09, and then lastly, since this one is bigger than it, it will be chosen as that. So else break. And so we'll say that encounter is equal to valid encounters E, and we'll get the ETH valid encounter. Thank you for catching that, by the way. So this will extract the encounter that will still be valid out of the list, and just as a proof of concept or whatever, in the case where it's just 1, where it's a 1.0, we need to flip this. Yeah, there we go. There we go. So now this will just be subtracting it down. So if the odd, which is like a 1.0, if it's 1.0, it's not going to be, yeah, because if it's less than, then that's when we modify it. If it's greater than, then we get it. Good. And now we're going to say self.pool.append encounter. So this encounter is now added into our pool of encounters. We haven't done anything to actually create this encounter object or create our pool out of anything, but we have created just one function where each time we get a new set of encounters, like route 1, these are our options, and route 2, these are our options, we have kind of a framework we can kind of work with to see which ones are available. So now let's do initialize. We're gonna do limit mode. We're going to do I think that's all we need to initialize it with. The pool to be empty. We're going to say self.limit mode is equal to limit mode. Limit mode is for which starter you have, because your starter might impact your future encounters, like Pokemon Black. In Pokemon Black, you get certain Pokemon based off of what your starter was. You can get Panpour, Pansage, or Pansear. So we're saying limit mode A is where you get Snivy, limit mode B is where you get Tepig, and limit mode C is where you get Oshawott. In fact, actually, I need to add the A, B, and C. I just realized I don't have the A, B, and C right there. There we go. And also our pool is going to be empty at the start. So that's going to add encounters to our pool. And then the next thing that we're going to do is we're going to say self.update pool. And here we're going to have a dictionary of Pokemon that we're going to say, actually we'll do, instead of update pool, we'll say remove from pool. And we'll pass in a list of dead Pokemon. Pass in a list of fainted Pokemon to remove them from the ongoing pool. That way, when Pokemon faint in battle, we can then remove them from the pool of valid Pokemon to use in team building, so that they won't get used again. And that's just as simple as saying something like self.pool is equal to Poke for Poke in self.pool if not in dead Pokemon. And that's that. So now we have a way of initializing it, a way of adding encounters, and a way of removing from the pool. And also, our end condition is if we wipe in battle, so we don't need to manage that here in this encounter pool. It's just if the result of a battle is a loss, then we just lose. Okay, so there's encounter pool. And then we also need a class which is an encounter. This is going to be a just a simple base model from Pydantic, import base model. That will have a couple of things. We'll have the ID, which is a string. We'll have the, oh, we don't need commas. We'll have the Pokemon, which will be a Pokemon object. Which a Pokemon object is from Pokémon.environment.pokemon. There we go. And I think that's all we. Oh, we also need odds, which will be a float. So potential encounters, we'll say from typing import list. If I can type. This is a list of encounters. And it's just going to be appending this thing into the pool. And actually what we're going to do is into pool, we're going to append encounter.pokemon. Because we just care about the Pokemon. We no longer care about where we got that Pokemon from or anything like that. And that'll just make it easier. So dead Pokemon will just be a list of Pokemon and not a list of encounters with the odds or anything like that. So this is able to be used, and we can start constructing this this run. So this is building teams off of the battle DF. We then want to build encounter. Do we want to build encounters? Let's check out our Excel spreadsheet. So run will have things like start, what encounter ID you're permitted to get, different battles with what encounter ID you're allowed to get, and so on and so forth. And encounters will have all of that. So inside of a single run, if we have the run, do run, where we want to give it a the whole list of everything. There's a couple of different things that we want to do. So inside of a run, we definitely want to construct all the teams. So we're going to say teams is equal to build teams. We're going to create the pool. Actually, let's set limit mode. For now, it's just gonna always pick Snivy unless you tell it otherwise, just for simplicity's sake. And then we're just gonna go inside of the battles. So for team in teams, these are each of the challenges in order. Do each battle in order from start to finish. This is just the showdown teams. So we should probably do for team for battle in battle df.index. Enemy team is equal to teams battle. If battle df dot look battle ID, if encounter pool dot limit mode not in the battle ID, we're just going to continue. Basically, this is to eliminate the duplicates that in each battle ID you have a different version, or in some of the battle IDs you have different versions depending on which starter you picked, because you only have one rival fight with Bianca, one rival fight with Sharon at the beginning, not 6 across all the different options. So we're just going to say if it's if your limit mode is not in there, then you're just going to skip it. Yeah, right now we're iterating over the index. We could iterate over some other column, but if we want to access multiple things, it's probably easier just to iterate over the index. We've already written this function that can construct a Pokemon Showdown team off of that. In this case, no, we don't have multiple entries per index. The index is unique, so we're okay. And it's just going to be like 1, 2, 3, 4, so on and so forth. No, there's no group by. We're basically treating this as just like a log of all the different trainers in the game, each assigned a unique ID. And if there's duplicate battles based off of a versioning, then we do an A, B, or C, so that it's identifiable. There's obviously better ways of doing this and more succinct ways of storing it. But this way, if we want to run each battle, we could just go through each element of the spreadsheet. And if it's a valid battle, like it's for our starter, we can pull the showdown team that's associated with this thing and challenge it using our AI. Okay, so in this case, if the battle isn't for our starter, skip it. Additionally, we should probably add some sort of column here about whether the battle is required or not. But as for that information, just from looking a little bit on my own, I wasn't really able to find out which battles were required. So it might involve just like a playthrough of the game. Who knows, maybe I'll just play through the game on stream as well. I don't know if that would be something worth doing. And that'd seem a little bit overkill just to find out which trainers are required or not. But if I can find a list of which trainers are required and which ones aren't, then I'll add another column there so we can just add that other condition. But yeah, so if it's not for our starter, in the future, also skip optional battles. Okay, so what we're going to do is we need to then simulate the battle. Or actually, no, we need to team build. So our team is going to be equal to team build, model path, or maybe just model, encounter. Cool. And team build is also going to give a showdown capable team. But for now, this is just going to probably just give some sort of like dummy value while we continue on with our development. Because the long-term AI, just to kind of show this stuff real quick, because I see we have some new viewers, is that we're kind of doing two different things for our AI. We are doing a team building AI part. Actually, this is probably a less good visual. Let's do this one. There's two different components to our AI. There's the team building part, where we will see the opponent's team use reinforcement learning and the rules of the Nuzlocke to then provide what team to use. We're using showdown formatting right now because our battle simulator, while we're training our model and while we're doing this simulated run, will be using showdown to run the battles. Additionally, so our format of choice is showdown to store the team information in. It also allows us to host our own private showdown server on my local computer, so we can actually see the games in showdown. This is just a sample battle between two of the trainer AI that we wrote earlier. Best move player just picks the move that does the most damage to the opponent, and then random player just picks random moves. So we can actually see the battles go live in showdown and replay them and see everything like that. Yeah, I'll move that back over here. And then the other part of our AI is obviously the battling. After you have a team, this is a different way of doing reinforcement learning. We will have the current game state of what Pokemon you have, what Pokemon the opponent has, your stats, your moves, their moves, everything that goes on in a Pokemon game. And you'll want to pick the best course of action, which is basically which move to use or which Pokemon to switch to. Those are your only actions, so the action space of this kind of AI is actually relatively limited. Unlike chess, where you might have like 50 different moves, the actual actions to take are relatively limited at any one point in time. Typically, it'll just be 4 for each move, plus 5 for each of the Pokemon that you could switch to. So just 9 different actions, which makes this actually very possible to learn. What makes it challenging is the fact that your Pokemon and its stats and the opponent's Pokemon and their stats and all the different status conditions and environments, there's a huge amount of combination there. So you really need to train a model to be able to learn very well on what's going on in order for it to be any good. So we're training 2 different models, one for team building, one for battling. And right now we're just kind of putting together a framework of how things are going to look in code so that we can just kind of enter in some dummy values. So like team build, it'll be passed a model so that it can run things. It'll be passed the encounter pool, so it knows what Pokemon are relevant for it. And it'll be passed the opponent team. Or I guess we'll stay consistent and call it enemy team. With this, we have enough information so that we can team build. And this is going to return some string, which is a showdown formatted battle team, so that we can simulate the battle. So we're going to say our team equals team build based off of team build model is equal to, none for now. And then battle model is equal to none for now. So we'll pass in the team build model. We'll pass in the encounter pool, and we'll pass in the enemy team. These are the 3 inputs, because both the encounter pool and the enemy team will be going into the model so that it can make the prediction on what team to use. Okay, so after we've built the team build will then tell us what Pokemon to use. And then we will simulate the battle. So we'll say that enemy player is equal to from dot trainer AI import game or import Gen 5 AI player. That's what it was. Equals Gen 5 AI player. And the team is going to be the enemy team. Ooh, I should also pass in the name so that we can name it, but we can modify that in a later time because it's almost midnight, so I'm probably gonna wrap up stream soon. Add the name as a username for style points. That way, whenever it shows Showdown, it doesn't show Game AI. It shows the name of the trainer that you're facing off against. Just because I think that's a neat thing to do. Our player is going to be, the name generator AI. At least just picking out of there's already random Pokemon names and random trainer names and all that type of thing we could do, just so it nicknames all of your Pokemon. That would be in the encounter pool. Whenever we pick a random encounter, instead of just appending that Pokemon, also adding a nickname to it. That would be a good idea, so that it feels more personal. Because right now it's just adding the Pokemon as is with no nickname. So our player, we're gonna do from player AI import, I don't know, probably something like player AI. I don't know. We haven't made it yet, so for now we're just kind of trying to framework it out so that we can figure out from a layout perspective if this makes sense. And again, our team is going to be our team. And yeah. Then using our PokeEnv library, there's a way of having 2 AI challenge each other. So what we can do is we can go here. Let me pull up that code. There we go. Await player 1 battle against player 2. They're just gonna do 1 battle. And then we'll have to check the history to see if they lost and what the replay was. Let me see if that's something we can do real quick, just off of a player object. Yeah, it's better than just naming your variables I, IJ or something. At least it's slightly more memorable there. So there's just a there's just an attribute called battles in this player object, but I don't know what battles is. Oh, I guess there we go. There's an attribute called N1 battles. Since we're creating a brand new player object each time, we can just see, did you win? Is your number of 1 battles 1? So if our player dot battle against enemy player, that way whenever we view it, we'll view it from our perspective. If our player dot n 1 battles is equal to 1, we won. Now we need to find our losses and remove from the pool. So there's a attribute called battles, but I'm not sure what it is. We might have to do some investigation, some digging down to find out what battles is. But our recent battle is going to be our player dot battles -1, and we'll need to dig into recent battle to find which Pokemon fainted. Remove. So this is going to be something like dead Pokemon equals that. Remove fainted Pokemon from the pool. Once they've been removed, then whenever we team build in the future, that pool won't have them anymore, so they're not valid Pokemon to use in the team building stage. So we'll say dot remove from pool, dead Pokemon. Oh yeah, if we lose, we just print the run has failed here at battle number battle. We can print and pretty that up to show more information, but basically the run's over, so it returns false. If it returns a true, then it's a success. Or maybe we could return how many battles it won or something. It's going to remove them from pool. All right. And lastly, we need to add more encounters if that battle allowed us to find more encounters, which is a possibility. So we can say if or we can say battle ID is equal to, yeah, let's just do this. ID is equal to that, not in battle ID. If battle ID in run, not, yeah, run df.index unlocked encounter is equal to run df.loc battle ID ID. This will be a list of encounter IDs. Yeah, because a run will unlock potentially multiple encounter IDs. Maybe just one, but potentially multiple. And then we will so it's actually area IDs that it's referencing, not encounter ID. So maybe we should specify that slightly better, or rename our column slightly better. So relevant encounters is equal to encounter df, where encounter df area id dot is in unlocked encounters. Okay, and then the last thing would just be transform this data frame into a list of encounter objects based off the odds, and for each different unique encounter ID, we'll be adding them to the pool. So this is our framework of doing a run. There's obviously a couple of things that still need to be implemented in order for this to be runnable, but I think there's nothing stopping us from doing this. There's no blocking point. All of this is possible given just some time and development work. So next Tuesday will be the next day that we're working on this, because I alternate projects Tuesdays and Thursdays. But yeah, so if you're watching on YouTube, I stream this whole process live on Twitch. This is basically the end of part 3 of this process of developing a machine learning based approach to Pokemon battling and Pokemon Nuzlocking specifically. The whole process is streamed live on Twitch. The VODs are then uploaded on YouTube as well as on Twitch. Edited down versions of the VODs are what you might be watching right now on YouTube. And after a whole project is done, the whole project will be summarized in just one video that'll be uploaded on YouTube. So for now, I think that's it for today, for both the stream and for part 3. So please, if you like the content, feel free to follow me on Twitch or subscribe to the channel on YouTube. All the links are in the description or on the About page on Twitch. Thank you so much for watching. I'm gonna head to bed. Thanks, everybody.